Hidden deep within the frozen expanse of Siberia, where winds carve through endless taiga and rivers vanish beneath ice, old Soviet logs whisper of phenomena that defy explanation. Survey teams and patrols meticulously documented landscapes marked by sudden hollows, strange lights, vanishing paths and shadowy figures moving silently among jagged ridges. The entries speak of forests where echoes behave strangely, salt-encrusted craters appear without warning, and wildlife manifests in forms that puzzle even experienced trackers. Journeying through these remote wildernesses, the logs reveal patterns of the unexplained intertwined with the stark realities of isolation, permafrost, and uncharted terrain. Each account draws a line between recorded observation and the unknown, offering glimpses of mysteries that linger beyond the reach of maps or conventional understanding. As we trace these paths and examine the detailed records, the Siberian wilderness reveals its quiet, enigmatic secrets, challenging both perception and reason. The vanishing survey team of the Putana Plateau. The Putana Plateau has long been associated with a set of expedition notes that describe the disappearance of a small Soviet survey team, an incident that entered internal archives with only a brief explanation and a series of increasingly troubled observations. The early pages of the logbook spoke of routine geological mapping on one of the most isolated basalt plateaus known, a region marked by deep canyons, stepped escarpments, and glacial valleys that remain among the least visited terrains on Earth. The team's assignment involved documenting rock exposures across a cluster of remote ridges northwest of Lake Vivi, and the entries reflected the precision expected from Soviet field crews who spent months in such landscapes under strict reporting schedules. Yet the later pages carried a tone that stood sharply apart from earlier confidence, as if the plateau itself had shifted from a difficult worksite into something that pressed against every attempt to understand it. Movement across the Putana Plateau often required long traverses along high, wind-sculpted corridors where the sound of boots on stone echoed for surprising distances. The logbooks described this echo effect in exact terms, noting that the basalt walls amplified even the smallest sounds in ways that confused depth perception. One observer recorded that the team relied heavily on compass bearings because acoustic reflections distorted spatial judgment, especially in narrow canyons where voices seemed to bounce between walls without any consistent direction. These environmental details were not unusual for the region, yet the recorded changes in sound behaviour 2 weeks into the mission suggested something that could not be explained by ordinary geography. At one camp, a topographer wrote that the faint tapping of their survey rods appeared to continue long after the rods were still, as though the plateau carried the noise across unseen cavities in the rock. The terrain itself reinforced the isolation. The Putana region contains some of the oldest flood basalt formations on the continent, and the logbooks often referenced its significance in geological research. Vast cliffs formed by ancient volcanic events created tiered structures that rose in geometric patterns, while deep lake systems cut through them in long, cold trenches. The survey team documented these features with interest, noting that the uniform layering of basalt occasionally broke into unusual columns formed by cooling fractures. One particular ridge displayed a sequence of columns that bent inward in a subtle arc, and the recorded sketches attempted to capture the curvature with as much accuracy as possible. Later reviewers of the logs remarked that the team's notes gave no indication of instability at the site, yet the curved formation became one of the final documented positions before the crew vanished. Weather patterns on the plateau often shifted without warning, a fact acknowledged in the meteorological sections of the logs. Sudden fogs drifted across the ridges from hidden watercourses, covering entire valleys in dim light. The team repeatedly expressed concern about how quickly visibility collapsed in these conditions, especially when working near canyon edges that dropped abruptly into lakes hundreds of meters below. One entry described the fog lifting to reveal an expanse of cliffs painted with mineral stains that shimmered faintly under diffuse light, creating the impression that the plateau was glowing from within. The writer insisted that the effect came from moisture trapped within the stone rather than any unusual luminosity, but the image lingered in the pages as a moment of uneasy beauty in a place where small errors carried serious consequences. Despite these atmospheric notes, the survey team remained consistent in its documentation of daily progress. The logs itemized samples collected from several outcrops, and one entry described basalt fragments containing distinctive olivine crystals common in Siberian volcanic formations. The team's geologist also noted the presence of permafrost wedges along some valley floors, reflecting long-term freeze-thaw cycles characteristic of the region. These factual observations anchored the mission in routine field science, yet the section that followed presented an abrupt narrative shift. A series of entries described faint metallic echoes heard from beyond a canyon wall late in the evening, sounds that repeated at irregular intervals and did not resemble animal movement or weather-related noise. Attempts to trace the source of these echoes resulted in several reconnaissance trips across the plateau's upper terraces. The team moved toward the direction where they first heard the sound, crossing a ridge that opened into a wide depression marked by scattered boulders. The logbooks noted no signs of recent rockfall, no tracks on the thin soil, and no evidence of camps or equipment left by other crews. Despite this, one observer wrote that the echoes grew more distinct near the depression, becoming sharper and clearer, almost like intermittent strikes on a hollow metallic surface. The writer mentioned that the sound appeared to originate from multiple angles, moving too quickly to pinpoint. This detail forced the team to consider the possibility of sound reflecting through a complex set of natural channels within the basalt, though none of them had encountered such behaviour elsewhere on the plateau. As days passed, the logs documented escalating tension among the group. Supply inventories remained accurate, and weather conditions showed no anomalies that could have compromised navigation. Yet several entries mentioned a persistent feeling of being observed from higher terraces, accompanied by impressions of movement on distant ridgelines that vanished whenever the team attempted to confirm them through binoculars. The plateau's immense scale made such impressions easy to dismiss, but the repetition of these notes suggested a creeping uncertainty that eroded the group's confidence. The growing unease surfaced most clearly in a final recorded observation, where one surveyor described hearing footsteps pacing along the canyon edge above their camp during the night, though no tracks were visible the next morning. The disappearance itself was documented only through absence. Rescue crews sent to locate the team found a fully intact campsite with equipment arranged in precise order, suggesting no hasty departure. Instruments were neatly stored, cooking gear remained unused from the previous evening, and the fire pit contained ash consistent with a controlled burn. The only irregularity emerged from the surrounding stone surfaces, where rescuers reported hearing faint echoes similar to those described in the logs, though none could determine their source. With no footprints leading away from the site and no evidence of a struggle or environmental collapse, the search team concluded that the plateau did not explain what had occurred. Long after the reports were filed away, the Putana Plateau still held the unanswered questions of the missing team, as if the echoes they heard remained hidden somewhere in its basalt corridors. The Kanti River footpath that reappeared. Along the quiet bends of the Kanti River, early Soviet field notes described a stretch of exposed earth that formed a precise footpath where no trail had existed the day before. The logs explained that the riverbank should have remained soft from recent seasonal melt, with silt still settling into shallow depressions and vegetation clinging to the unstable ground. Yet the observers found a strip of earth that seemed untouched by the natural disorder of the surrounding terrain, a line of compacted soil running parallel to the water, with no tracks leading to or from it. The appearance of this footpath, so cleanly defined and sharply edged, conflicted with everything known about the unpredictable patterns of the region's riverside landscapes, and mentioning its sudden emergence so early in the team's records showed just how deeply it unsettled them. Across the wide expanse of the Obertish Basin, the river's shifting edges revealed the unstable nature of the soil that made stable footpaths nearly impossible to maintain. This part of western Siberia was dominated by thawing permafrost, spring swells, and banks that softened under even moderate rainfall, all of which contributed to constant erosion. Soviet surveyors were trained to expect abrupt changes in river contours, from slumping embankments to fresh sediment layers deposited by shifting currents. Their routine hydrological measurements often included soil density checks, waterline documentation, and notations on seasonal flood behaviour, as the rivers flowing through these low-lying plains altered their courses with surprising speed. For a well-formed trail to appear along such a variable and unstable corridor contradicted the patterns these crews had recorded for years, Within the first pages of the expedition's log, the team recorded their surprise at finding a smooth, compacted track that ran parallel to the water in a way that seemed almost deliberate. They described the trail's surface with the same technical clarity used for geological samples, noting that the top layer of earth was pressed into a firm, continuous plane, free of the rippling usually caused by wind or water. Small stones embedded within the path followed a uniform distribution, as though pressed downward at the same moment rather than scattered naturally over time. The absence of any tool marks, boot prints or cart tracks led the observers to rule out human interference, and the riverbank's isolation meant that the nearest settlement lay far beyond the reach of casual travellers. The team sketched the path's alignment carefully, tracing its length across the bank with instruments they used for mapping boundary lines and sediment zones. Beneath the sparse vegetation along the bank, the team noticed disrupted frost patterns and smoothed patches of mud that hinted at a disturbance with no identifiable source. Frost crystals, usually aligned in random clusters at the start of the cold season, had formed unevenly around the edges of the path, creating a thin, broken boundary between untouched ground and altered soil. Nearby grass blades were bent uniformly toward the river, as if pressed down by a broad, weightless sweep rather than by footsteps or animal passage. In another section, a strip of moist earth displayed faint parallel striations that lacked the depth characteristic of mechanical dragging or natural water flow. Every clue pointed toward an event that did not fit the documented behaviour of the riverbank ecosystem, leaving the observers with measurements that deepened their questions rather than clarifying them. Further upriver, long-standing Kanti and Mansi communities had long read the land with remarkable accuracy, yet none of their seasonal knowledge accounted for a path forming in dry conditions along an eroding bank. These communities traditionally used temporary trails across frozen rivers during winter, navigating by reading ice thickness, vegetation changes, and wind-packed snow along the banks. They knew where the river would swell during spring thaw, where the banks would collapse in summer rains, and where animals would cross during migration periods. Their understanding of terrain was built on centuries of close observation, and even they would not have expected a stable footpath to emerge during the mild months, especially along a section known for unpredictable shifts in soil composition. The Soviet logs reference past consultations with local inhabitants on river behaviour, making the anomaly even more striking. When Soviet hydrologists reviewed the measurements, they compared the observations with known processes of thermokarst collapse and sediment redistribution, finding no alignment between theory and what the team had documented. Thermokarst activity often produced irregular depressions, ridges and unstable ground caused by melting ice lenses beneath the surface, but it never produced straight compacted lines. Erosional retreat from receding water could flatten soil surfaces, yet it left a soft texture vulnerable to even light pressure, unlike the firmness the team observed. Subsurface heave caused by freeze-thaw cycles created lifted mounds, not pressed tracks. Every mechanism that shaped Siberian riverbanks contradicted the characteristics of the path, leaving the hydrologist to focus on the team's precise sketches and soil samples, which only emphasized the anomaly rather than explaining it. By the second week of surveying, the path itself appeared to shift locations overnight, moving in gentle arcs that defied any natural pattern of erosion or human construction. The logs noted that each morning, the team found the path displaced by varying distances, sometimes several meters inland, sometimes closer to the waterline, yet always maintaining a consistent width and soil texture. The only changes came from its course, which bent in subtle curves as though drawn by an unseen hand responding to a river that refused to remain still. The soil composition remained firm and uniformly compacted, even when the newly positioned section overlapped ground that had been visibly soft the previous evening. This movement introduced a new layer of uncertainty, suggesting a process that worked silently and invisibly during the night. After a series of autumn storms swept across the region, the crew found only scattered traces of compacted soil beneath a fresh layer of silt, leaving the bank as featureless as it had been months before. The storms deposited enough debris to obscure any surface details, yet the team's final entries reported that fragments of the former path could still be detected where the silt was thin. These remnants lay in faint, linear patterns that dissolved under a light touch, offering no stable measurements or clues as to how the earlier formation had maintained its structure. the survey ended shortly afterward, leaving behind a record that captured the perplexity of observers who had spent their careers studying landscapes that did not behave in such precise and fleeting ways. Even now, the Kanti's changing shoreline seems to suggest that whatever shaped that elusive footpath may still be moving beneath the river's restless edge. The Tunguska Silence Zone. The first log entries noted an absence that could not be ignored. Birds did not sing, insects did not hum, and the usual stir of small mammals was gone from an entire clearing. Surveyors recorded the phenomenon with meticulous care, measuring soil temperature, wind speed, and ambient light, yet every conventional indicator suggested a normal day in central Siberia. The unusual quiet extended across a section of forest dense with larch, birch, and pine, a region typically alive with sound even in the chill of late spring. Only after repeated measurements did the crews record its precise location near the Podkamennaya Tunguska, noting that within this area, every sound seemed dampened, muted, or absorbed before it could travel any distance. The anomaly was not subtle. It imposed a strange weight on the senses, creating a hollow stillness that unsettled both human observers and the usual woodland rhythms. Ordinarily, these forests thrummed with life, a constant layering of sound from wings, rustling leaves, and flowing streams, making the sudden stillness all the more unsettling. In the surrounding expanse, Siberian jays called across the canopy, red squirrels scuttled along fallen trunks, and distant rivers rippled over stones, producing the familiar acoustic backdrop for any field survey. Within the silence zone, however, these sounds seemed to evaporate, either failing to reach the ears or appearing as faint hollow echoes, devoid of the richness found outside its boundaries. The discrepancy between normal sound propagation and the peculiar absence recorded in the logs emphasized the severity of the anomaly and encouraged repeated verification of instruments and observation points. Surveyors recorded the disquiet in meticulous detail. Wind moved through branches, yet no familiar chorus accompanied it, leaving only an empty resonance that seemed almost deliberate. The logs described moments when a crew member would clap or call, hearing their own noise returned faintly or delayed, as if filtered through layers of invisible damping. Small mammals that normally darted through undergrowth froze, leaving paw prints that ended abruptly, unconnected to any observed movement. The pattern of stillness was so consistent across multiple sites that the surveyors could not attribute it to chance or a single disruptive event. It was as though the forest itself had entered a state of quiet compliance, a condition that human senses and instruments alike struggled to quantify. Thermometers, barometers, and humidity gauges showed nothing unusual, and every standard measure of weather and soil condition contradicted the silence that dominated the area. Air temperatures aligned with long-term averages for the region, while barometric readings fluctuated within expected limits. Ground temperatures indicated no anomalous heat or cold that might drive animal activity underground, and moisture levels corresponded to nearby wetland observations. Even the permafrost beneath the shallow topsoil displayed no unusual thawing or settling. In short, the physical environment did not explain the profound muting of life and sound, leaving crews to record the impossibility itself as a primary observation. Subsequent teams discovered that this quiet was not isolated, noting similar zones miles apart, each marked by a sudden disappearance of movement and sound within its bounds. Survey notes described multiple clearings, often aligned along old river terraces, where the same effect manifested in the presence of typical Siberian fauna. Migratory birds avoided these spaces, or when they passed, their calls carried only as faint whispers. Insects that normally filled the forest floor with vibration and song were absent, leaving leaves and twigs undisturbed. The replication of these zones across the Tunguska forests suggested a pattern too deliberate to dismiss, and repeated mapping attempts failed to reveal any connection to human activity, water channels, or magnetic anomalies previously documented in the region. Scientists considered magnetic anomalies, permafrost shifts, and local microclimates, yet none could explain why the effect occurred with such precision and consistency. Measurements of geomagnetic fields were largely within the expected range for the Siberian craton, and thermal monitoring showed standard permafrost stratification. Small variations in microclimate, such as subtle shade or localized humidity, could account for minor changes in wildlife behaviour but not the total suppression of sounds over dozens of metres. Even the thick layer of moss and peat common in Tunguska wetlands could not account for the nearly perfect attenuation of sound or the systematic absence of movement observed in these areas. Those who entered the silent zones described an uncanny muffling of their own actions, from footsteps to whispered conversation. Logs included accounts of crew members pausing mid-step, noting that even breathing seemed to lack resonance, that voices returned as hollow echoes or vanished entirely before reaching another person. In several instances, an entire team would move across a clearing and later find no tracks beyond the outer boundary of the zone, as though their presence had been partially absorbed into the landscape. The psychological weight of these experiences was noted repeatedly in the logs, underscoring a sense of unease that extended beyond physical measurement, a recognition that human perception itself was affected by the phenomenon. By the time crews departed, edges slowly returned to their normal hum of life, while the core remained undisturbed, leaving the observers with meticulous measurements that provided no answers. Logs documented the gradual return of bird calls and the cautious reappearance of small mammals along the periphery, yet the central areas remained as silent as when first observed. Even repeated surveys in subsequent years revealed the same pattern. The zone persisted, stubbornly resisting explanation, and the borders shifted slightly but predictably, always maintaining the central absence. For scientists and surveyors alike, the Tunguska Silent Zone remained a recorded anomaly that defied both ecological understanding and expectations grounded in decades of Siberian fieldwork. Even decades later, travellers speak of clearings in the Tunguska forests where sound vanishes as if swallowed by the ground itself. The frostbit beacon of Lake Taimir. A pale, flickering glow hovered above the frozen surface, painting the ice with a spectral shimmer that seemed almost alive against the long winter night. The expanse of Lake Taimir stretched endlessly, its frozen plains interrupted only by jagged ridges of ice formed where wind and current collided over centuries. The light appeared unexpectedly, a vertical shaft of pale blue that rose from the ice in places where the snow was thickest, illuminating frost crystals that normally sparkled only in sunlight. Observers noted that the glow was concentrated in a particular area near the southern reaches of the lake, a point easily distinguished even in the darkness of the polar night, yet its origin was entirely untraceable. It was as though the lake itself had conjured a beacon, and while teams of scientists and surveyors recorded its position carefully, the phenomenon remained entirely divorced from any known human or natural cause. Lake Taimir's vast expanse usually lay silent under snow and ice, subject to brutal polar winds, temperatures that plunged well below freezing, and months of near-complete darkness. Winter temperatures often fell below -30 degrees Celsius, while wind chill could make the air feel even more extreme, freezing exposed skin in minutes. Ice thickness in the central basin reached over 2 meters, supporting the weight of sleds and small vehicles, yet cracks and pressure ridges were constant reminders of the lake's shifting surface. Aurora borealis often swept across the northern sky in brilliant green and purple curtains, yet the frostbit beacon differed from these natural light shows, appearing as a compact, localized phenomenon unaffected by the magnetic currents that energized the auroras. Despite these extreme conditions, the light remained remarkably stable in position, visible over several nights, and sometimes even during brief, storm-driven snowfalls that would normally obscure any reflection. Observers travelling across the northern ice reported seeing the light flare at the same location repeatedly, seemingly anchored despite the drifting snow and shifting ice flows. Soviet survey teams who patrolled the area recorded exact coordinates using theodolites, sextants, and improvised markers etched into the ice. Measurements were cross-referenced with atmospheric conditions. Air temperature, barometric pressure, wind speed, and ice depth were all logged meticulously. What made the beacon unusual was that it consistently appeared in the same place under radically different conditions, during clear nights, heavy snowfall, and even amid fierce winds that reshaped the surrounding snowdrifts. The repeated observations suggested a persistence beyond temporary reflection or refraction, confounding theories that relied on simple optical illusions or auroral effects. The beacon's form was elusive, sometimes a thin vertical shaft, sometimes a wider halo, its intensity waxing and waning with no discernible pattern tied to sunlight or moonlight. In certain instances, observers described the light as pulsating gently, almost breathing as though it were aware of those watching it. Snow and frost grains near the source glimmered unnaturally, reflecting the pale light with a consistency that no natural phenomenon could explain. In some logs, the glow was recorded as faintly shifting along a horizontal axis by mere meters, despite being anchored within a precise observation zone. These subtle changes were enough to convince surveyors that they were witnessing something neither stationary nor entirely natural, a presence both delicate and deliberate on the frozen lake. Natural explanations were considered by scientists such as ice halos, diamond dust, or light refracting through thin air layers, but none matched the consistent position and timing recorded over the years. Ice halos, caused by sunlight refracting through ice crystals in the atmosphere, were ruled out because the glow often appeared during complete darkness or dense snow cover. Diamond dust, common in polar regions, could reflect ambient light but was transient, dispersed, and lacked the intensity and focus the beacon displayed. Refracted light from distant settlements or solar reflection across the ice was impossible due to the remoteness of Lake Taimir. The nearest outposts were tens of kilometers away, and no human activity was recorded during the beacon's appearances. Even the theory of bioluminescence or chemical luminescence from trapped gases beneath the ice failed under scrutiny, as spectroscopic analysis indicated no chemical reactions or emissions from the ice itself. Teams noted that the phenomenon persisted across changing ice thickness, overcast conditions, and variations in wind, marking it as both rare and remarkably stable. Logs recorded the appearance of the light in midwinter when ice thickness reached its peak, and again during the late thaw when snow cover had partially melted and ice flows shifted. In every case, observers attempted to replicate or explain the effect using controlled light sources or reflective panels, yet the frostbit beacon persisted unaffected. Its recurrence, documented across years of expeditions, defied the natural variability of Lake Taimir's frozen surface, and its appearance became a central focus of Soviet polar research. The stability of its location amid such an inhospitable and mutable environment lent the phenomenon an almost sentient quality, as if the lake itself directed its illumination. Those witnessing it often described an eerie mix of beauty and unease, the cold itself feeling sharper, the isolation heavier, as if the light carried a silent weight beyond its visible presence. Surveyors remarked on a strange sensation of time elongating near the glow, an optical and psychological distortion that accompanied the physical observation. Frostbite risk, extreme isolation, and polar night disorientation all contributed to the crew's heightened awareness, yet none reported hallucinations or errors in measurement. Every documented account reinforced the credibility of the phenomenon. The frostbit beacon remained stubbornly present, and observers returned repeatedly to confirm its patterns, fully trained in extreme weather observation and survival in Arctic conditions. Even seasoned teams were drawn to it with a mix of scientific curiosity and unspoken apprehension. Despite repeated observation, no instrument, measurement, or meteorological record fully explained the glow, leaving Lake Taimir as a place where ice, light, and atmosphere converge into an enduring mystery. Surveyors ultimately left the area with detailed sketches, coordinates, and spectrographic readings, all of which confirmed a luminous presence but offered no mechanistic explanation. Attempts to model the phenomenon using known physics, ice crystal optics, or auroral dynamics failed to replicate the beacon under controlled conditions. For decades, its cause remained elusive, a persistent anomaly in one of the most extreme and remote regions of Siberia, where the frozen lake seemed to harbour a secret visible only to those willing to brave its cold expanse. Still, the frostbit glow may flare across the northern ice, a beacon whose origin remains unreadable beneath the endless cold and darkness. The Kadar Ridge stone spirals. Circling patterns of stones emerge from the ridge like frozen whirlpools, their symmetry striking against the jagged terrain and loose scree. From a distance, the spirals appeared almost deliberate, a stark contrast to the chaotic scatter of rocks that typically covered the slopes of Kadar Ridge. The formations were concentrated along a series of elevated terraces, where wind had stripped soil to reveal bare rock and exposed fragments of granite and feldspar. Surveyors noted that the stones themselves varied in size, some no larger than a fist, others heavy enough to require several men to lift, yet each lay meticulously arranged, concentric and continuous. Even under the harsh northern light, shadows traced the curves and arcs with unnerving precision, suggesting a design that was both intentional and enduring. Though no human activity had been documented in this remote section for centuries, the presence of these spirals hinted at a deliberate manipulation of the landscape, a mystery preserved by isolation and permafrost. The Kadar Ridge rises sharply above the surrounding valleys, its rocky slopes carved by millennia of frost, wind, and seasonal thaw, yet the spirals seem untouched by typical erosion. The ridge stretches hundreds of meters in elevation, punctuated by cliffs, gullies, and scree slopes, where permafrost and freeze-thaw cycles constantly reshape the surface. Vegetation is sparse. Patches of tundra grasses, lichens, and hardy shrubs cling to fissures, yet the stones of the spirals remained almost entirely free of moss or displacement. The harsh climate, long bitter winters with sub-zero temperatures, short summers, and powerful prevailing winds would normally scatter any loose rocks, yet the integrity of the patterns persisted. Even in areas where seasonal meltwater ran along the slope, diverting small stones and sediment, the spirals remained remarkably intact, their layout seemingly resistant to both natural decay and environmental pressure. Soviet surveyors first catalogued the formations during aerial reconnaissance, noting their precise layout, diameter, and orientation relative to the ridgeline and nearby cliffs. Photographs from fixed-wing aircraft revealed dozens of spirals, some overlapping, others aligned in apparent sequence along the ridge. On-the-ground teams measured the stones, recording diameters ranging from 10 to 30 meters and counting concentric layers that sometimes reached 15 stones across. Each survey included bearings and elevations, triangulated to ensure consistency, and all subsequent expeditions confirmed the observations. Logs repeatedly emphasized the unusual regularity of the spirals, the way they maintained symmetry even across uneven terrain, and the consistency of orientation along the ridge, which appeared to follow neither magnetic north nor any discernible astronomical alignment. Each spiral varied in size, some wide enough to require careful navigation to cross, with concentric layers of granite stones, arranged with remarkable regularity. Observers noted that the stones were stacked only minimally, often laid flush with the ground rather than piled, enhancing the visual continuity of the spiral's form. In several instances, smaller stones filled gaps between larger boulders, a detail that suggested deliberate care rather than random geological deposition. Lichen and frost patterns indicated that the stones had been undisturbed for decades, possibly centuries, yet their arrangement suggested intelligent placement rather than natural sorting by freeze-thaw processes. The overall effect was both geometric and organic, a shape so precise that it seemed almost impossible to reconcile with the randomness of the surrounding landscape. Geologists debated whether the formations arose from natural periglacial processes, ancient ritual construction, or some combination, yet no explanation fully accounted for their consistency and scale. Periglacial phenomena such as frost wedge polygoning, solifluction, and frost heaving can produce linear arrangements and patterned ground, but none create circular concentric spirals with consistent layering. Archaeologists noted that nomadic cultures in the region had left stone markers, cairns, and other ceremonial structures, yet the scale of the Kadar Ridge spirals far exceeded anything previously documented, and the isolated placement rendered regular human access difficult. Attempts to link the formations to astronomical alignments, such as solstice markers, yielded no consistent correlation. Every proposed explanation contained gaps, leaving the spirals suspended between geology and the possibility of purposeful human creation. Mapping over successive expeditions revealed that the spirals repeated along the ridge at intervals that defied typical geological randomness, yet they were separated by treacherous terrain that challenged surveyors' measurements. Between individual formations, gullies, and steep inclines interrupted continuity, yet the pattern seemed to continue along a consistent line visible from higher elevations. Survey logs recorded distances between spirals ranging from 50 to 200 meters, noting that even minor deviations maintained a proportional relationship that suggested deliberate planning. Harsh wind, snow, and unstable rock required survey teams to proceed cautiously, often measuring sections in multiple passes to ensure accuracy. Despite these obstacles, repeated mapping confirmed both the precision and repetition of the spirals, reinforcing the notion that they were not accidental or ephemeral. Explorers described the experience of walking among the spirals as disorienting, a combination of awe and subtle unease amplified by icy winds and the harsh isolation of the ridge. The stones formed continuous curves that guided the eye along paths impossible to follow completely on foot, giving the impression of intentional movement or instruction encoded in the ground itself. Sparse vegetation added to the effect. Tundra grasses and lichens accentuated the arcs, while snow and frost highlighted contrasts along the curves. The northern light, low even in summer, cast elongated shadows across the spirals, exaggerating their symmetry and making the formations appear to shift subtly as the observer moved. Observers reported a palpable sense that the spirals were designed to be seen from above, a pattern meant for observation that no lone traveller could easily interpret on the ground. Although detailed records, photographs and sketches exist, the spiral's origin and purpose remain an enigma, standing in silent testimony atop one of Siberia's most inhospitable ridges. Survey teams departed with comprehensive measurements, but returned again and again to confirm what had been seen, yet every expedition failed to uncover any human artifacts, tools or remains that could explain their creation. Geological analysis confirmed that the stones were local, yet their arrangement defied natural deposition patterns. The spirals endure across centuries of frost, wind and erosion, maintaining a geometric precision that intrigues geologists and archaeologists alike. For anyone who climbs the ridge, the formations convey a sense of deliberate mystery, frozen in both time and the harsh northern environment. Seen from above, the Kadar Ridge spirals continue to appear like frozen hieroglyphs, etched into the earth, their intent unreadable and their origin untouched by time. The Evenki Drumming Valley. A steady hollow rhythm echoed through the dense taiga, vibrating against tree trunks and frozen soil in a cadence that no observer could trace to any source. At first, the sound was subtle, a low thump that might have been dismissed as falling branches or shifting ice, yet it persisted night after night in a remarkably consistent pattern. The valley's contours seemed to carry the beats with unusual clarity, amplifying the sound as it bounced from ridges and frost-hardened riverbeds. Local Evenki hunters, accustomed to the natural rhythms of the wilderness, described the drumming as unmistakable, a deliberate percussion resonating through the frozen landscape, and they drew the attention of regional research teams who arrived to investigate the phenomenon with logs and instruments in hand. The Evenki Valley lies hemmed in by steep ridges and scattered permafrost lakes, its rivers winding through dense conifer forests that amplify every sound under the cold northern sky. Winters stretch for months with snow covering much of the valley floor, while the surrounding ridges funnel wind through natural channels, creating microclimates of biting chill and ice-laden gusts. Permafrost underlies much of the valley, stabilizing the forest but also cracking with subtle groans as it expands and contracts in response to temperature fluctuations. These conditions provided a backdrop against which the drumming seemed to emerge, carrying a resonance uncharacteristic of ordinary ice or wind noises, and making the valley a naturally isolated acoustic chamber that intensified its mystery. Field teams and forestry crews recorded the drumming with compasses, stopwatches and meticulous logs, noting the direction, intensity and duration of each occurrence with growing perplexity. Observers timed the pulses, noting a rhythm that sometimes persisted for minutes and occasionally paused as abruptly as it had begun. Using triangulation methods, teams attempted to locate the source, but measurements consistently produced conflicting results, suggesting that the sound did not emanate from any single point. These records, preserved in Soviet-era survey logs, indicated that multiple observers, independent of each other, heard the same phenomenon under comparable conditions, providing a foundation for serious consideration rather than anecdotal accounts alone. The sound itself defied simple description, sometimes resonating like distant timber strikes, other times a hollow thump that seemed to circle the listeners, shifting with the wind yet anchored within the valley. At times, the beat felt almost musical, a repeating pattern that implied intelligence without explanation. Frosted riverbanks and snow-laden branches appeared to contribute echoes, but the precise tempo and clarity suggested something more than incidental amplification. Teams noted the way the vibrations interacted with the terrain, accentuating natural hollows and depressions, yet disappearing when observers attempted to approach, as if retreating into the valley itself. The effect was both mesmerizing and disorienting, leaving even experienced wilderness travelers uncertain of what they were hearing. Experts proposed explanations ranging from ice cracking in frozen streams to echoes bouncing off rock faces, yet none aligned with the precise timing, repetition, or location documented across multiple expeditions. The natural acoustics of valleys often produce unusual echoes, but in this case, the beats maintained a rhythmic regularity inconsistent with random ice fracture or falling debris. Wildlife was also ruled out. No animals in the region produced consistent, loud, drum-like percussive sounds, and tracks in the snow never corresponded with the timing of the pulses. Even atmospheric phenomena like sudden gusts of wind or temperature inversion could not account for the predictability and directional qualities of the sound, leaving observers without a definitive explanation. Repeated observations suggested a pattern. The drumming often appeared during early twilight or near sudden temperature shifts, yet the source could never be located despite careful triangulation. Teams noted that the sound sometimes coincided with still, cold evenings, when air density would carry acoustic waves farther and clearer than during windy or stormy conditions. On several occasions, the beats emerged simultaneously in locations separated by hundreds of meters, creating the illusion of multiple sources. Measurements of sound velocity and direction were meticulously documented in logs, yet no method could reconcile the apparent movement of the rhythm across the valley. The phenomenon demonstrated a level of consistency that seemed to defy natural randomness, reinforcing its enigmatic status. Evenki guides spoke of spirit drums long before official teams arrived, and those who listened closely described an uncanny sense of rhythm that stirred both awe and unease in the cold isolation. Local tradition held that unseen forces communicated through percussive sounds, signaling territorial boundaries or marking seasonal changes. The guides' familiarity with the valley's acoustics and weather patterns lent weight to their accounts, and many suggested that the drumming was not merely a natural occurrence but something embedded in the landscape itself. Observers, trained in rational observation, often found themselves acknowledging an inexplicable interplay of sound, terrain, and perception, a phenomenon that refused to fit conventional explanation. Careful measurement, acoustic modelling, and repeated field investigations failed to reveal the origin of the drumming, leaving the phenomenon suspended in mystery amid the valley's fog and snow. Logs detailed attempts to recreate the sounds with mechanical instruments, yet the acoustics could not replicate the clarity, tonal quality, or timing of the natural beats. Even high-powered microphones and directional recording devices captured the sound imperfectly, sometimes exaggerating or distorting its qualities. The drumming seemed to possess an intelligence of location and timing, appearing precisely when conditions were favourable, yet vanishing before it could be fully analysed. Each expedition left the valley with an unresolved sense of awe, carrying records, maps and sketches but no conclusive answers. Travellers continue to report the valley filling with drumming from unseen hands, a cadence that weaves through the taiga and vanishes as mysteriously as it begins. The white fur elk of Yenisei Basin. A ghostly figure moved along the riverbank, its white fur stark against the dark taiga, capturing the attention of the hunters who first chronicled the unusual sight. At a distance, the animal appeared almost spectral, moving with a careful grace that suggested both awareness and adaptability in the harsh Siberian environment. Hunters described its coat as a luminous white, different from the muted browns and greys of the typical Siberian elk, and noted the unusual breadth of its antlers, suggesting a strong, healthy adult male. These sightings, initially thought to be anomalies or misidentified individuals, became part of repeated observations recorded in Soviet-era ecological logs, drawing the attention of both scientists and forestry personnel to the Yenisei Basin's remote corridors. The Yenisei Basin stretches across vast floodplains and dense conifer forests, its rivers carving channels through frozen ground and snow-laden terrain, offering both isolation and shelter for wildlife. Summers are short, with rivers swelling from thawing snow and ice, while winters plunged temperatures well below freezing, blanketing the basin in snow and ice for months. The forests are dense with larch, spruce and Siberian pine, interspersed with bogs and permafrost patches that limit human access but provide concealment for wildlife. Within this harsh, expansive environment, the white-fur elk could move undetected for long periods, allowing it to survive where human presence is minimal and predation patterns differ from other regions. Early Soviet ecological logs recorded the elk in scattered notes, documenting herd size, behavior, and precise locations along tributaries, confirming that multiple observers witnessed the phenomenon independently. Observers detailed encounters in which a lone elk or small groups appeared along river bends, grazing quietly before vanishing into thick forest. Coordinates were noted with unusual precision, and repeated observations indicated that these animals were not accidental wanderers, but seemingly residents of the basin, returning to the same valleys across seasons. Hunting and forestry teams were instructed to document fur coloration, antler structure and behavior, creating a body of evidence that suggested these elk were a rare but persistent anomaly within the Siberian ecosystem. The elk grazed cautiously along the edge of marshes and open meadows, its movements deliberate, pausing to lift its head at distant sounds or approaching footsteps, displaying a vigilance that puzzled trackers. Even experienced hunters found themselves unable to approach closer than several hundred meters without startling the animals into retreat. Observers noted a blend of wariness and confidence in the elk's behavior, a combination that suggested adaptation to both natural predators and occasional human presence. Tracks in snow indicated that these elk moved in predictable patterns, following seasonal routes along riverbanks and through low valleys, yet they consistently avoided high traffic areas, making prolonged observation difficult and frustrating those attempting to study them systematically. Researchers considered albinism, seasonal shedding, and environmental adaptation as possible explanations, yet the consistency of fur coloration and size suggested something beyond ordinary mutation. Albinism can result in pale fur, but the absence of pink eyes or other typical albinotic traits raised questions. Seasonal shedding could lighten winter coats, but the animals remained strikingly white even during summer months. Genetic studies of Cervus elephas sibiricus indicate that mutations leading to pale pigmentation are rare, yet in the Yenisei Basin, multiple individuals with the same coloration appeared over successive years. These facts, recorded meticulously in Soviet logs, highlighted the anomaly, a population that consistently exhibited a rare physical trait, surviving in one of the world's most challenging wildernesses. Sightings repeated along specific valleys and river bends, with the elk appearing at dawn or twilight and disappearing into dense forest, eluding attempts to photograph or track them over extended periods. Even with camera traps and field observers stationed for weeks, documentation remained fleeting. Some sightings were corroborated by multiple teams arriving from different directions, confirming the elk's presence rather than misidentification. Observers reported hearing the soft padding of hooves on snow or frozen ground before the animals appeared, yet the sudden vanishing of the herd suggested an intelligence or instinctive awareness far beyond the random behavior typical of wild elk. These elusive habits reinforced the perception of the elk as both ordinary and extraordinary, creatures that could coexist with humans while remaining profoundly mysterious. Evenki and other indigenous accounts spoke of pale elk as forest spirits or omens, weaving local belief into a tapestry that complemented the empirical observations of biologists and hunters alike. Stories told of white elk appearing at times of seasonal change, guiding or warning travellers, or appearing on quiet riverbanks during hunting expeditions. These oral traditions, passed down for generations, were taken seriously by both locals and scientists, who noted that the animal's behaviour often matched the descriptions in legend. The intersection of folklore and factual observation created a sense that the Yenisei Basin's white-fur elk were not merely unusual animals but symbols embedded in the cultural and ecological landscape, enigmatic presences that defied easy categorization. Although carefully logged and studied, the white-fur elk continued to evade full scientific understanding, its presence lingering as a living enigma within the Yenisei wilderness. Researchers compiled extensive records, including sketches, notes on antler structure, herd movement patterns, and precise geographical coordinates, yet none could conclusively explain the population's origin, genetic stability, or unusual coloration. Even extensive surveys of predators, habitat conditions, and seasonal climate patterns failed to reveal why the elk remained rare, elusive, and geographically restricted. Each year, new sightings are added to the record, reinforcing both the reality of the animals and the impossibility of fully understanding their persistence in such an isolated environment. Amid the frozen forests and winding rivers of the Yenisei Basin, glimpses of pale elk continue to vanish into the shadows, leaving the wilderness echoing with unanswered questions. The disappearing river barrels of Kolyma. Barrels laden with timber and supplies vanished from sight as they drifted along the icy currents of the Kolyma, leaving observers at downstream checkpoints baffled. River patrols reported reaching sections where the barrels had been observed just hours earlier, only to find empty channels and undisturbed ice along the banks. The cargo ranged from essential supplies for remote forestry outposts to timber cut from the surrounding taiga, yet the scale of the losses was never trivial. Logs from Soviet-era transport teams documented the incidents with precision, noting coordinates, river conditions, and environmental observations, highlighting that these disappearances were consistent enough to attract both curiosity and concern among officials tasked with maintaining supply lines in the harsh northern wilderness. The Kolyma River winds through vast tundra and conifer forests, its channels shifting with the seasons and its banks often masked by ice, snow, and hidden tributaries. During winter, the river freezes solid, creating a deceptive surface that hides submerged channels and sudden drop-offs, while in spring, melting snow sends torrents of icy water racing downstream. Floodplains expand and contract according to rainfall and meltwater, carving temporary channels and leaving islands of debris in their wake. These conditions made navigation unpredictable and created opportunities for materials to vanish, as barrels could be caught in undercurrents, ice jams, or side channels invisible to observers stationed along the main river course. Soviet forestry logs meticulously recorded the disappearance of barrels at multiple river segments, noting dates, cargo types, and witness accounts that confirmed the phenomenon was neither isolated nor accidental. Teams documented instances in which barrels loaded with logs would leave one checkpoint and never arrive at the next, despite careful timing and coordinated patrols. Repeated losses were logged in the same river stretches, and multiple independent teams confirmed the pattern. These records were not casual reports, they were detailed observations, including notes on water level, ice thickness, river width, and weather conditions, suggesting a combination of natural complexity and inexplicable disappearance that defied ordinary logistical explanations. Crews attempted to track the barrels using floats, patrols, and observation posts, yet thick ice, rapids, and frozen side channels consistently thwarted every recovery effort. Even teams equipped with ropes, poles, and temporary dams found that barrels could not be intercepted. Observers watched as the timber-laden containers vanished under ice bridges or were swept into hidden tributaries, sometimes reappearing much later, miles downstream, sometimes never at all. Seasonal changes compounded the mystery. Thawing rivers could deposit barrels in unreachable swamps, while sudden freezes trapped them beneath ice layers until they became impossible to locate, erasing any clear trail of their movement. Natural explanations were considered. Violent currents, shifting ice flows, submerged channels, and the sudden release of pressure from winter ice might account for some losses, but never for the totality of each disappearance. Hydrological studies of the Kolyma showed that ice flows and meltwater could create temporary whirlpools, undercurrents, or surges capable of carrying debris off the main river path. Fallen trees and hidden sandbars created hazards that could trap or divert floating objects. However, logs consistently indicated that some barrels vanished in calm stretches of river or were last seen moving slowly downstream, where none of the obvious dangers could account for their disappearance, leaving investigators puzzled by the apparent selectivity of the losses. Surveys of the riverbed revealed sudden drops, submerged channels, and pockets of trapped ice that could snare barrels long before they reached downstream checkpoints. During winter months, river ice could shift abruptly, creating underwater crevices or temporary dams, while spring floods often carved new channels, diverting debris into hidden side streams. In some areas, sonar and rudimentary depth measurements detected clusters of barrels partially buried beneath sediment or ice, suggesting that the river itself acted as both conveyor and vault. Logs noted that barrels sometimes reappeared months later, displaced miles from their original route, or not at all, indicating that Kolyma's shifting topography combined with ice dynamics and permafrost erosion, contributed significantly to the phenomenon while still leaving gaps in understanding. Patterns emerged over the years, with barrels vanishing in the same river stretches during thaw or after storms, suggesting that the phenomenon followed an invisible logic tied to the river's hidden currents. Some stretches of river were notorious among forestry teams, often called dead waters or ghost bends for the way supplies and debris seemed to disappear there repeatedly. Teams began timing shipments to avoid these areas during certain times of year, yet losses continued, indicating that the river's behaviour was inconsistent and perhaps influenced by forces that could not be anticipated solely through observation. Seasonal shifts, sudden ice breaks and unexpected floods all contributed to a sense that the river itself was an unpredictable participant in the mystery. Local hunters and river crews told of ghost waters, where objects seemed to dissolve into the river, blending folklore with the meticulous logs of those who recorded losses systematically. Some spoke of barrels vanishing at night, returning days later in distant river bends, sometimes empty or partially submerged, as though guided by unseen hands. These stories were often dismissed as exaggerations, yet they persisted alongside the factual records, lending a spectral quality to the Kolyma's reputation. Tales of vanished supplies, drifting barrels, and erratic river behaviour created a layered perception of the landscape, where empirical observation and local lore intersected in ways that reinforced the river's enigmatic character. Even with repeated investigation, careful observation, and detailed river charts, the barrels continued to disappear, leaving both the rivers and their human witnesses in perpetual uncertainty. Teams developed maps, flow models, and contingency plans, yet no method could fully explain the repeated losses. Each expedition added more data, yet the phenomenon persisted, demonstrating that human understanding of the river's movements remained incomplete. The repeated vanishing of barrels became a reminder that, even in the age of meticulous record-keeping and scientific measurement, the vast Siberian wilderness retained elements beyond comprehension, capable of quietly asserting its own rules over both man and material. Along the icebound stretches of the Kolyma, barrels still vanish between observation points, leaving the river to carry only whispers of what might have been. The Amur forest lantern sightings. The Amur forests of eastern Siberia, vast and nearly impenetrable, had long been the subject of scientific surveys, yet even the most precise instruments occasionally recorded phenomena that eluded explanation. During winter nights, infrared monitors deployed by forestry research teams picked up small, mobile heat signatures flickering over the dense woodland floor, readings that could not be matched to known wildlife, human activity, or controlled fire. The devices, calibrated to detect even minor thermal variations across the frost-covered landscape, registered patterns that repeated in multiple locations, leaving technicians puzzled and sparking questions about the source of these luminous anomalies. Soviet-era logs later noted similar events, though these entries focused on the environmental context, reporting unusual thermal readings without attributing them to any identifiable cause. Timber transport crews navigating frozen rivers and narrow forest corridors frequently encountered lantern-like lights hovering above bogs or glinting between trees. These lights would often appear for a few moments before vanishing into the tree line or shifting across clearings at unexpected speeds. Crews reported sudden changes in temperature when near the lights, describing the phenomenon as simultaneously captivating and unnerving. Over years of repeated observations, multiple independent teams corroborated the presence of these luminous occurrences, adding to the growing body of data suggesting the phenomenon was consistent, yet inexplicable within known physical or biological frameworks. During early winter, the forest's long nights and extreme cold amplified the effects of light interacting with ice-coated foliage, snow-laden branches, and frozen bogs. Reflections from distant campfires or patrol lights occasionally produced glimmers mistaken for lanterns, though analysis of timing and location eliminated many of these possibilities. Yet, not all recorded events could be explained by reflective phenomena. Some infrared readings occurred in areas devoid of any light source visible to the naked eye. The seasonal conditions of the Amur forests thus acted as both a canvas and a filter, intensifying subtle phenomena while masking the forest's hidden complexities, creating a space where optical anomalies could take on a seemingly autonomous life. Analyses of multiple sightings revealed that the lights tended to cluster along specific ridgelines, river corridors, and frozen marshes, suggesting a pattern that went beyond random occurrence. Mapping these sightings over time revealed corridors where the phenomenon appeared more frequently, forming a network of zones that researchers began to monitor more closely. Observers noted that even within these zones, the light's behaviour was inconsistent. They would sometimes split into multiple smaller glows, merge, or move in ways that appeared intentional, yet no physical forces or environmental explanations fully accounted for their coordinated appearance. These patterns challenged the understanding of the forest as a passive landscape and hinted at an underlying mechanism yet to be discerned. To capture the phenomenon more systematically, researchers placed motion sensors, thermal cameras, and light-sensitive instruments in locations where sightings were historically frequent. These devices intermittently recorded the lantern's fleeting presence, confirming that the events were not merely illusions of the human eye. In several instances, cameras documented the appearance of small, luminous orbs rising above frozen bogs or hovering over moss-covered terrain. The instruments were unable to track sustained movement or provide precise measurements, as the lights often flickered and disappeared faster than the sensors could respond. Despite technological assistance, the lanterns maintained an air of autonomy, frustrating attempts to fully capture their nature or explain their behaviour with conventional physics. Scientific explanations were proposed, including bioluminescent fungi that emit faint light during decomposition, marsh gases such as methane igniting briefly in cold air, or optical refraction through frost and ice crystals. While each hypothesis accounted for certain aspects of the light's appearance, none fully explained the phenomenon's consistency, mobility, or occasional vertical shifts. The recurring infrared signatures, combined with corroborated human observations, suggested that the lights were more than fleeting reflections or natural chemical reactions, leaving a considerable gap between empirical data and comprehensive understanding. Acoustic measurements recorded near the lantern hotspots revealed occasional faint vibrations, low-frequency hums, and subtle rustling that seemed unrelated to wind or animal activity. Sensors picked up subtle oscillations in the air and snowpack during some lantern appearances, hinting at energy transfers or localized atmospheric anomalies that coincided with the light's movement. Logs noted that these sounds were brief, often imperceptible to humans but measurable with sensitive instruments, adding another layer of mystery that distinguished the phenomenon from ordinary bioluminescence or reflections. These acoustic signatures suggested that the forest lanterns were accompanied by physical effects beyond mere visual perception, creating an unsettling sense of presence and interaction with the environment. The elders of the Evenki and Nanai peoples described forest spirits guiding travellers with soft lights, a form of benign guardianship embedded in local belief systems. Their narratives often coincided with locations where researchers and forestry crews repeatedly recorded lantern sightings, creating a rare intersection of cultural memory and empirical observation. These accounts provided historical continuity, suggesting that the phenomenon had been witnessed long before modern instruments were deployed, even if its nature remained unexplained. For the locals, the lanterns were not a scientific puzzle but a persistent feature of the forest's living presence, demanding respect and caution. Together, historical observations, modern sensor data, environmental conditions, and cultural narratives created a layered record of the Amur forest lanterns. Each perspective provided insight, yet failed to offer a conclusive explanation. The lights were fleeting and inconsistent, appearing in patterns that could not be predicted but persisted enough to defy dismissal. This interplay between observation and elusiveness made the lanterns a defining feature of the forest winter nights, a reminder that human understanding, though systematic and diligent, remained limited when faced with the Siberian wilderness in all its complexity. Though instruments fall silent and snow blankets the Amur forests, the enigmatic lanterns persist, flickering in defiance of explanation. The Ob Plateau Windless Storm. The Ob Plateau, a sweeping expanse of permafrost and rolling plains, had long been considered inhospitable to both human settlement and detailed study, yet Soviet survey teams and meteorologists noted a phenomenon that defied conventional understanding. Snow could swirl in violent eddies across open plains, while anemometers recorded complete stillness, leaving observers puzzled and, at times, unnerved. Logs from patrols documented sudden drops in temperature accompanied by visual turbulence in snow and ice, but without the presence of wind, gusts, or measurable air movement. The paradoxical nature of the storm drew attention not only for its intensity but for the mystery of its very mechanics, recorded meticulously over decades yet never fully explained. High plains stretched beyond the horizon, punctuated by deep river valleys and pockets of taiga, shaping an environment where weather patterns were both extreme and isolated. The frozen rivers reflected the pale light of winter skies, and scattered groves of larch and spruce cast long shadows over the frost-bound land. These geographic features ordinarily dictated predictable wind flows, guiding storm fronts and shaping snowdrifts, yet the windless storms appeared indifferent to topography. Observers noted that the plateau's unique combination of elevation, permafrost, and surrounding lowlands seemed to create conditions ripe for anomalous atmospheric events, though no existing model could account for the peculiar absence of wind. Teams caught within these storms reported an otherworldly quality to the experience. Frost clung instantly to clothing, snow swirled around boots and equipment in apparent motion, and ice crystals glittered mid-air as if suspended by invisible hands. Some teams described disorientation when navigating familiar terrain, noting that the swirling snow seemed to mask landmarks and distort distance. While the temperature dropped sharply, the air felt unnervingly static. Without wind to carry sound or movement, the forest and plains fell into a surreal silence broken only by the shifting snow. These human accounts, combined with meticulous log entries, emphasized the sensory contradiction between the storm's visible ferocity and the calm of the surrounding atmosphere. Historical records confirm that these windless storms were not isolated incidents. Over the course of late winter and early spring, recurring entries documented nearly identical phenomena occurring along the same ridgelines, lowland depressions, and river valleys. The frequency suggested that the storms were not random. They followed a seasonal rhythm, appearing with sufficient regularity to be noted as patterns in meteorological logs. Yet these records also highlighted anomalies. Some storms lasted mere minutes, while others persisted for hours, all without any recorded air movement. This repetition, coupled with variation in intensity and duration, reinforced the enigmatic nature of the phenomenon. Meteorological instruments provided tantalizing yet incomplete data. Barometers recorded pressure fluctuations consistent with a storm system. Thermometers documented rapid drops in temperature, and snow gauges measured accumulating precipitation, yet anemometers consistently registered zero wind speed. Researchers were confounded by the contradiction. Every measurable aspect of the storm suggested dynamic energy, yet the essential indicator of airflow was absent. Attempts to correlate the events with larger weather systems, jet stream anomalies, or regional climate patterns yielded little insight, leaving the storms as enduring anomalies in otherwise well-understood atmospheric science. Various hypotheses were proposed to explain the windless storms. Katabatic winds, which occur when cold air flows downslope, could theoretically produce some localized effects, yet these winds could not account for the sudden onset or the swirling motion of snow observed far from slopes. Microclimatic inversions and frost heaves were considered, and small-scale turbulence from temperature gradients was examined, but all failed to fully reproduce the documented intensity or the unique stillness of the air. Each theory could explain fragments of the phenomenon, yet none offered a complete answer, emphasizing the gap between observation and understanding. Anomalies that seemed to defy conventional physical explanation were also recorded by observers. Snow crystals occasionally formed suspended patterns in mid-air, and fine powdery drifts rotated in miniature vortices without any measurable airflow. Frost appeared to build on surfaces in complex formations within minutes, forming spires, sheets, and delicate lattices that seemed impossible under calm conditions. These effects, consistent across multiple recorded storms, suggested that the windless storms were more than a simple meteorological curiosity. They were an active and enigmatic force interacting with the plateau's frozen landscape in ways that confounded expectation. Sunlight interacting with these windless storms produced unusual optical effects, as reported by observers. As the low winter sun skimmed across the plateau, drifting snow caught in the air refracted light into fleeting spectral glows, creating shimmering halos and transient patterns across the frozen ground. shadows of rocks and trees are sometimes elongated or warped unnaturally, giving the impression of movement independent from the storm itself. Surveyors noted that these visual anomalies were particularly pronounced at the edges of swirling snow clouds, as if the frozen particles were bending light according to some hidden geometry. Combined with the tactile and auditory paradoxes of the storm, these ephemeral visual phenomena heightened the sense that the plateau was operating under rules beyond ordinary perception. Local folklore provided additional context for a phenomenon that had both scientific and cultural resonance. Kanti elders spoke of frozen tempests that arrived without warning, striking with cold and swirling snow yet leaving the air calm and silent. Tales described how travellers caught in such storms would lose their bearings, with landmarks disappearing under moving drifts while the forest or plains remained eerily still. These oral histories, passed through generations, aligned with documented locations of windless storms, suggesting that the phenomenon had been observed long before modern instruments were deployed, and that the land itself seemed to possess a memory of its peculiar atmospheric behaviour. In spite of decades of observation, measurement, and theorising, the windless storms of the Ob Plateau remain an unresolved natural paradox. Each season, they appear with their signature combination of intensity and stillness, leaving both experienced surveyors and meteorologists humbled. Historical logs, human experience, scientific data, and cultural memory together paint a layered record of the phenomenon, yet they collectively underscore its elusiveness. The storm's sudden onset, visible turbulence, and silent air defy conventional meteorology, suggesting that even well-studied environments can harbour mysteries that remain impervious to human understanding. Over the frozen expanse of the Ob Plateau, snow still dances without wind, as if the land itself has learned to move in silence. The Yakut salt crater phenomenon. The Yakut plains are vast and desolate, a frozen expanse where snow and permafrost dominate every horizon. Yet, amidst this barren landscape, a series of crystalline hollows appeared unexpectedly, their stark whiteness cutting sharply against the muted greys of winter. Soviet survey logs first noted these depressions during geological expeditions, recording circular formations that ranged from a few meters to over 20 meters across, their surfaces encrusted with bright white salt deposits. Some craters emitted faint wisps of vapor in the early morning, though no geothermal activity could explain the phenomenon, and the surrounding snow remained perfectly still. Surveyors expressed both curiosity and unease in their notes, documenting what appeared to be a process beyond ordinary natural expectation, a strange interplay of mineral deposition, environmental conditions, and unknown forces. Remote plateaus and deep river valleys stretched in all directions, the terrain marked by frozen ridges, scattered taiga, and ice-bound streams that rendered access slow and often treacherous. Seasonal thaws were brief and patchy, leaving the soil hard as stone for most of the year, yet these conditions did not prevent the rapid appearance of crystalline hollows. Winds were sporadic across the plains, and the extreme cold limited most biological activity, making each new crater an unexpected anomaly. The isolation of the region compounded the mystery, as expeditions required careful planning, and the chance to observe a crater as it formed was rare, leaving logs as the primary record of their existence. Soviet geological surveyors recorded each crater with meticulous precision, noting diameters, depths, and peculiar surface patterns. They measured the angle of sloped walls, collected samples of the encrusted minerals, and sometimes sketched the surrounding terrain to capture the context. One entry described a crater whose interior seemed almost perfectly circular, with radiating salt veins forming faint spiral patterns, a formation that did not correspond to typical erosion or sedimentary processes. Observers consistently emphasized the rapidity with which the crystals appeared, often noting that depressions which had been surveyed one year returned months later with expanded deposits and sharper, glistening formations. The uniformity of some shapes contrasted with the scattered irregularity of the landscape, suggesting an influence that was both localized and precise. Laboratory analyses of collected samples revealed mineral compositions dominated by sodium chloride, with traces of sulfates and other evaporites. The crystalline structures formed unusually quickly for the prevailing conditions, and some deposits displayed intricate lattice-like patterns rarely seen in natural salt flats. Logs recorded instances where thin sheets of translucent salt appeared almost overnight, creating surfaces that reflected the pale light of the winter sun. Chemical readings also noted minor variations in pH and mineral saturation between craters, indicating that while the process had similarities across multiple formations, subtle environmental differences produced unique results in each location. These measurements suggested the presence of an underground source, yet none was definitively identified. Over several seasons, repeated surveys revealed that these craters often formed in clusters, some appearing near river depressions and others isolated atop ridges, with no apparent hydrological or topographical connection. Surveyors noted that the formation seemed to follow a hidden pattern, as though an unseen mechanism governed where and when a new hollow would appear. Logs recorded observations of craters growing incrementally over months, while new depressions appeared suddenly, reinforcing the sense that the phenomenon was active rather than entirely passive. Despite their methodical tracking, researchers could not predict when or where the next crater would form, heightening the sense of mystery surrounding the salt formations. Geologists proposed multiple hypotheses to explain the strange craters. Underground brine pockets were suggested, with salt-rich water potentially seeping to the surface and crystallizing rapidly in the freezing air. Other theories included permafrost thawing in localized pockets, capillary action drawing mineral-laden water upward, or even microbial activity catalyzing crystallization. However, none of these explanations fully accounted for the precise circular shapes, the speed of formation, or the occasional rising vapors recorded in the logs. Each theory could explain fragments of the phenomenon, yet the combination of rapid deposition, geometric consistency, and atmospheric anomalies remained unresolved. Peculiar environmental effects accompanying the craters were also noted by observers. On calm mornings, faint wisps of vapor would rise from the salt surfaces, often dissipating before reaching more than a meter in height. Reflections from the crystalline surfaces created mirages, sometimes distorting the perception of depth within the depressions. Despite these visual cues of activity, the surrounding air and snow remained undisturbed, contributing to a paradoxical sense of motion within stillness. Some logs described light refracting in unusual patterns off the salt lattices, producing brief glimmers that vanished almost as soon as they appeared. These observations suggested that the craters were not merely mineral deposits but dynamic, interacting elements of their environment. Oral history from the Yakut people adds an intriguing dimension to the phenomenon. Elders spoke of white patches emerging suddenly on frozen ground, seen by hunters and travelers as mysterious hollows in the tundra. Stories described sudden changes in the terrain during the coldest months, with bright crystalline surfaces appearing where only snow and frozen soil had existed before. While these accounts were rarely precise in measurement, they corresponded broadly to the locations of craters documented in survey logs, suggesting that the formations had been observed long before modern instruments arrived. The convergence of oral tradition and scientific record lent a rare historical continuity to the mystery, bridging centuries of human observation. Though scientists have measured, observed, and theorized extensively, the salt craters of Yakutia continue to resist full explanation. Each season, survey teams encounter hollows with fresh deposits, irregularly distributed, and occasionally accompanied by unexplained vapors or reflections. Geologists, chemists, and meteorologists have all contributed insights, yet the complete mechanism remains elusive. The region's permafrost, underlying mineral layers, and environmental extremes create conditions ripe for mystery, leaving these crystalline depressions as enduring enigmas within an otherwise stark and unforgiving landscape. In the remote stretches of Yakutia, the salt craters glisten in silence, their perfectly circular hollows hinting at forces beneath the frozen earth that refuse to be named. The Northern Urals Shadow Trekker. The Northern Urals stretch as an unbroken expanse of jagged ridges, dense coniferous forests, and ice-laden ravines, where winter winds carve the terrain into a labyrinth of frozen obstacles. Survey teams navigating this remote wilderness in the Soviet era faced logistical challenges that tested both endurance and resolve. Yet the logs show that even amid routine mapping and geological study, subtle anomalies began to emerge. Snowdrifts shifted in peculiar ways, and occasional depressions in the undergrowth seemed freshly disturbed without explanation, prompting surveyors to record these events with a mixture of curiosity and unease. Though at first easy to dismiss as natural variations in terrain or effects of wind, these details, logged meticulously, hinted at an unseen presence threading the forest. Faint impressions in the snow and the whisper of displaced branches first drew attention, appearing sporadically along the survey route. Teams noted the prints were oddly spaced and oriented, often circumventing obvious paths yet maintaining a trajectory that suggested intent. The logs describe moments when these impressions seemed to anticipate the surveyors' own movements, appearing in areas they had recently crossed but where no one had ventured since. Even the most experienced trackers found it difficult to reconcile the patterns with the expected behaviour of wildlife, as the marks lacked identifiable claw or hoof traces, while their spacing and directionality defied human norms. In one particularly striking account, a team documented footprints partially obscured by drifting snow, each impression sharply defined yet unusually elongated. Measurements taken by surveyors suggested a stride length inconsistent with ordinary human movement, and the depth of the impressions implied considerable weight. Logs note attempts to follow the tracks, only to find them disappear abruptly among rocks or beneath overhanging branches, leaving behind an unbroken forest floor that betrayed no further passage. Such indirect evidence became a recurring motif, instilling a growing sense of perplexity among the survey parties. Over successive kilometres, similar patterns recurred with remarkable regularity. Broken twigs, bent grasses and compressed moss mirrored the surveyors' own paths, yet each time the trail diverged subtly, never allowing close observation or pursuit. Logs meticulously charted these occurrences, noting the locations with precise coordinates, which suggested the phenomenon had a predictable but incomprehensible pattern. Patrols sometimes returned to the same areas days later, only to find the traces vanished entirely, leaving no permanent mark beyond the initial observation, as though the forest itself had conspired to erase any evidence of the entity. The psychological impact on the teams was profound. Surveyors recorded a quiet tension that settled across the group, an awareness that movement within the forest was not solely their own. The combination of isolation, harsh climate, and repeated encounters with anomalies created a heightened state of alertness, amplifying every creak of frost-laden branches and every fleeting shadow across snow. Log entries describe altered routines, cautious movement through particularly dense stands of conifers, and the instinctive habit of scanning the tree line for patterns that might not exist. The forest became a stage where perception and environment intertwined, producing an almost palpable suspense. Gradually, direct observation became unavoidable. One twilight, a slender human-like silhouette appeared at the periphery of a ridge, moving deliberately yet vanishing whenever the eye tried to focus. Logs describe a fleeting impression of motion that defied the normal pace of walking or running, a fluidity that made it impossible to determine size, exact shape, or distance. The figure seemed to pause and survey the surveyors themselves, then melt back into the forest shadows without leaving additional traces. Such sightings were rare and brief, yet they left a lasting imprint on the memory of those who recorded them. Each glimpse was accompanied by environmental anomalies. Temperature readings dipped inexplicably near the points of observation, while distant echoes of movement or crunching snow sounded dislocated, as though originating from multiple locations at once. Branches sometimes quivered without wind, and snow patterns shifted subtly, aligning with the movements of the unseen figure. Logs reflect the surveyors' attempts to correlate these effects with natural phenomena, yet the anomalies persisted even when conditions were consistent, adding layers of mystery to each encounter. Subtle interactions between the shadow trekker and natural light were also noted by surveyors. In the early morning or late afternoon, when low sunlight filtered through the forest, elongated shadows occasionally appeared in locations where no observer or object was present. These shadows shifted in ways that mirrored the supposed movement of the figure, bending around tree trunks and ridges with an almost deliberate awareness of topography. Snow crystals sometimes glinted differently in these areas, catching the eye and reinforcing the impression of a moving presence. Such optical subtleties, combined with the fleeting impressions in snow and moss, created a layered puzzle, an entity that left traces perceptible through multiple senses, yet consistently avoided direct capture or measurement. Stories passed down locally added an extra dimension, lending cultural resonance to what surveyors had witnessed. Elders in villages along the lower Urals spoke of wandering silhouettes, shadowy figures that moved silently across ridges and valleys, often seen by hunters or travellers who ventured into the dense forests. These legends described the figures as elusive, sometimes appearing to observe without interfering, other times vanishing entirely at the moment of recognition. While folklore lacked the precision of survey logs, it mirrored the consistent patterns of sightings, suggesting a continuity of experience across generations that bridged traditional knowledge with documented observation. After repeated documentation, careful analysis, and meticulous mapping of the anomalous patterns, the shadow trekker remains unexplained. Each new entry in the logs reiterates the challenge of reconciling observation with expectation, as the forest, climate, and terrain provide no satisfactory explanation for the entity's behavior or presence. The phenomenon continues to elude understanding, leaving the northern Urals as both a recorded landscape and an enigmatic stage for a presence that resists definitive identification. Over the ridges and frozen valleys of the northern Urals, the shadow trekker moves in silence, a presence recorded in logs yet never fully seen or understood. The Lena Pillars Whisper Recordings. Nestled along the eastern banks of the Lena River, the towering Lena Pillars have long captivated explorers with their vertical spires of limestone and sandstone, some rising more than 100 meters above the river's surface. During the Soviet era, scientific teams tasked with surveying the remote Yakutsk region reported an unusual phenomenon that would quietly intrigue geologists, archaeologists, and later sound engineers: faint multitonal vibrations that seemed to emanate from the pillars themselves, persisting long after the surrounding forest and river had fallen silent. Initial expeditions in the early 1970s recorded what appeared to be subtle acoustic resonances, almost like whispers, travelling through the natural rock formations. These readings were captured using early Soviet seismographs and rudimentary hydrophones, instruments adapted for the extreme Siberian conditions, and yet the patterns they recorded did not match the known frequencies of wind, wildlife, or the distant river currents. Researchers noted that the pillars' sheer verticality and uneven surfaces created a complex acoustic landscape, but the sounds went beyond what could be explained by simple echoing or wind passage. The recordings revealed layers of tonal oscillations, some lasting several minutes, composed of low rumbles punctuated by higher-pitched, almost harmonic notes that appeared to shift and modulate spontaneously. Soviet teams experimented with various hypotheses, including microfractures in the rock releasing trapped gases or subterranean water flow resonating in unexpected ways, yet these theories failed to fully account for the consistency and musical quality of the vibrations. The most perplexing aspect was the temporal persistence. Even when teams left the pillars and returned hours later, the instrument still detected lingering vibrations as though the stone itself retained memory of the acoustic events. Local Yakut guides, long familiar with the river and its surrounding cliffs, offered accounts that gave the phenomenon an uncanny dimension. They described the area as alive with voices during quiet mornings, with the sounds resembling distant conversations or the echo of a human choir carried through hollow rock chambers. Anthropologists and folklorists who visited the site documented these oral histories, noting that the pillars had been considered sacred landmarks for centuries, sometimes associated with spirits of the river or ancient guardians of the land. This cultural resonance added layers of meaning to the scientific observations, suggesting that what modern instruments captured might have been entwined with a human perception of place and memory. Field notes from 1974 indicate that one expedition attempted to stimulate the pillars acoustically, using controlled hammer strikes and mechanical vibrations to see if the stones would respond. Surprisingly, the recordings showed that the induced sounds often merged with the existing whispering tones, creating interference patterns that resembled a call and response effect, as if the rock formations were answering the experimenters. Subsequent analysis suggested that the spire's mineral composition, primarily limestone with pockets of dolomite, allowed for unique resonance, and the vertical fissures could have acted as natural amplifiers for subtle vibrations. Despite these insights, the exact mechanism for why some pillars spoke and others remained silent remained elusive, leaving scientists to wonder whether the phenomenon was purely geological or if some other unrecognized factor was at play. Hydrogeological surveys later suggested that subsurface water channels running between and beneath certain pillars may act as natural conduits for sound, amplifying and modulating vibrations in ways previously unconsidered. Water-filled fissures, often invisible from the surface, could transmit low-frequency pulses across meters of rock, interacting with hollow chambers and creating interference patterns that altered pitch and duration. Seasonal changes in water level, combined with varying mineral deposits along the channels, may have contributed to the unique layering of tones recorded in both Soviet and modern expeditions. Yet even with these insights, the exact timing, persistence and harmonics of the whispers could not be fully explained, leaving the phenomenon as elusive as it was mesmerizing. Climatic conditions in the region may have played a role. Winter temperatures in Yakutia frequently drop below -50 degrees Celsius, and the freeze-thaw cycles in spring and summer stress the stone in irregular ways. Seismologists hypothesize that ice expansion in fissures could generate low-frequency hums, while mineral expansion during warmer months might produce the higher tones. However, even when environmental data were accounted for, the persistence and harmonic richness of the vibrations did not correlate perfectly with temperature, wind, or seasonal shifts. In some recordings, the vibrations appeared to anticipate shifts in air pressure, an anomaly that drew comparisons with natural resonant systems but remained unexplained. The Lena Pillars' remote location complicated research. Supplies and scientific equipment had to be transported by river barges or helicopter, and the region's isolation limited repeated observations. Still, detailed logs preserved in the Soviet archives document dozens of expeditions, each noting the same basic pattern. The pillars, at certain points, would emit tones and hums that seemed independent of external sources, as if the stone itself were holding and releasing sound. Acoustic engineers who later examined the declassified tapes were struck by the layers of complexity, identifying over a dozen distinct frequencies that interacted in ways unlike typical geological or atmospheric phenomena. The subtlety of the sounds meant they were often imperceptible to human ears in the field, requiring amplification for full study. Yet when played back, listeners reported an uncanny sensation of presence, as if voices were carried from another time or dimension. Attempts to model the effect digitally in later decades yielded partial insights. Computer simulations of wave propagation through the pillars' structures reproduced some tonal characteristics, particularly the long reverberations, but failed to replicate the precise harmonics observed in the field recordings. Some specialists suggested that microstructural variations in the limestone, combined with hidden cavities, could generate naturally complex resonance patterns, but these models remained speculative. The Soviet teams, constrained by limited technology and the difficulty of prolonged fieldwork, could only record, catalogue and carefully describe their observations, leaving the phenomenon largely unsolved. Even today, scientists and adventurers who visit the Lena Pillars report moments of eerie sound. Modern equipment detects vibrations that echo the early recordings, reinforcing the idea that this is not a transient or accidental occurrence. Researchers studying environmental acoustics note that the phenomenon may also interact with subtle geomagnetic or atmospheric conditions, hinting at a nexus of geology, physics, and the human experience of sound in extreme wilderness. The layered history of observation, combined with centuries of indigenous reverence, makes the pillars more than a geological oddity. They are a place where nature, memory, and mystery converge. Whatever the explanation, the Lena Pillars whisper not only through instruments and seismic logs, but through the lingering sense of the uncanny that touches every visitor who pauses long enough to listen. The Chara Sands footprint chain. Surveyors navigating the shifting dunes of Chara Sands first recorded a chain of footprints that defied ordinary explanation, each print stretching across the wind-scoured sand like the shadow of an unseen traveller. The anomaly was noted during routine Soviet desert patrols and geological surveys undertaken to map the unusual sand sea that lies within the Siberian landscape of Transbaikalia. Unlike the surrounding forested regions and river valleys, Chara Sands presents a strange pocket of desert, its ridges of fine quartz and mica sand bordered by coniferous woodlands and rocky hills. Patrols reported that the footprints persisted despite fierce winds and sudden storms, as if the desert itself resisted erasing the marks. Photographs and detailed sketches captured the chain, yet their origin remained completely unidentifiable. The Chara Sands desert occupies less than 30 square kilometers, yet its unusual location makes it one of Siberia's most peculiar ecological features. Formed at the base of the Kadar Mountains, it consists of sand deposits left behind by ancient glacial and riverine activity, shaped over millennia into undulating dunes and isolated ridges. Seasonal winds can reach speeds capable of levelling the surface, yet even during the most intense gales the footprints endured, astonishing every observer. Scientists who later examined the sand noted that its fine, dry composition would normally cause impressions to collapse or be entirely obliterated within hours. This resilience made the footprints an object of particular fascination, as they seemed impervious to both natural and human interference. Each impression measured over half a metre in length and nearly a quarter of a metre deep, suggesting immense weight and a stride inconsistent with any known Siberian fauna. The spacing between each print was uniform, forming a chain that extended for more than a kilometre in some areas. Patrols noted that while some prints appeared slightly distorted due to shifting dunes, the majority remained sharply defined, preserving the outline of toes or claws in a way that indicated deliberate placement. The scale and regularity of the chain ruled out natural erosion, falling rocks, or simple wind compaction, leaving the investigators puzzled about what or who could have left them. Official Soviet patrol logs from the 1960s recorded these observations in meticulous detail. Photographers documented the tracks from multiple angles, while surveyors mapped their coordinates with theodolites and compass bearings. Some teams returned weeks later, expecting the tracks to have vanished under the relentless desert winds, only to find them virtually unchanged. One log entry noted, "The prints maintain depth and alignment despite exposure to wind speeds exceeding 25 meters per second. No known animal capable of producing these dimensions is present in the region." These records formed the first formal acknowledgement that the Chara Sands footprints were not a fleeting anomaly, but a persistent and measurable phenomenon. Various hypotheses were proposed by scientists, each with its own shortcomings. Geologists suggested that strong pressure differentials in the sand or sudden shifts in subsurface moisture might create temporary depressions resembling footprints, but such processes typically result in irregular or short-lived impressions. Biologists considered the possibility of an unknown large creature, perhaps a relic species surviving in isolation, yet no physical evidence, bones, droppings or sightings supported this theory. Even aerial surveys revealed no movement, tracks or nests that could account for the chain, leaving experts to speculate on more exotic or unrecognised explanations, all the while noting the phenomenon's striking regularity and scale. While environmental factors offered clues to the print's persistence, the mystery remained unresolved. The desert experiences extreme temperature swings, with intense heat during the day and freezing nights, which can harden the sand surface into a crust capable of preserving impressions. Seasonal winds normally shift the dunes dramatically, yet in specific low-lying corridors between ridges, the sand forms relatively stable channels where tracks can survive longer. Still, these natural factors could not fully account for the footprint's unusually long chain or precise alignment, suggesting that another unknown factor was influencing their formation or preservation. The sand's composition, when analysed, revealed an unusual balance of quartz grains, mica flakes and clay particles, creating a surface that hardened more quickly than typical desert sand under diurnal temperature shifts. In specific low-lying corridors where the chains appeared most intact, the presence of fine clay lenses beneath the surface may have acted as a natural stabilizer, supporting the unusual longevity of the footprints. Even under high wind conditions, these microlayers prevented collapse of the impressions, preserving not only depth but the sharp contours of toes and claws. While this geological feature explained partial resilience, it could not account for the chain's scale, alignment, or persistence across the entire desert, leaving the origin and purpose of the tracks equally mysterious. Patterns of a peculiar nature were observed running along the chain. Some sequences formed slight arcs that curved predictably along the contours of the dunes, while others appeared almost perfectly straight, ignoring the natural undulations of the sand. Multiple expeditions recorded these formations independently, confirming that the chains were not accidental, temporary or artificially created. Measurements of stride length suggested a rhythm and consistency incompatible with random movement, yet the true origin, whether animal, human or geological, remained undetermined. The footprints were not isolated. In certain areas, smaller, seemingly related impressions appeared beside the larger tracks, hinting at interaction or accompaniment, though no corresponding body could be observed. All efforts, from repeated surveys to advanced analysis, could not account for the Chara Sands footprints. Soviet geologists, after decades of occasional field visits, could only record their dimensions, map their locations, and compare them with previous data. Modern researchers using high-resolution satellite imagery identified the chain's continuity, but found no disturbance that might indicate the passage of a vehicle, animal, or human. Some analysts speculated about subterranean activity or geological vibrations influencing sand formation, yet the correlation with known phenomena remained tenuous. The desert's isolation compounded the difficulty. Few scientists could conduct prolonged fieldwork in the extreme climate, and the sheer remoteness limited repeated, consistent observation. Through every expedition, the footprints maintained their quiet presence, etched into the sands with a permanence that confounded understanding. They stood as both evidence and enigma, a tangible yet unexplained trace in one of Siberia's most unforgiving landscapes. Scholars, adventurers, and local guides alike noted the same essential mystery. Despite extensive mapping, photography, and environmental study, no one had uncovered the origin, the purpose, or the maker of these enormous impressions. The prints endure in the desert's memory, a testament to a presence that remains unseen but undeniable. No one has yet followed the chain to its origin, and the dunes keep their secrets buried beneath every shifting ridge. The tinder forest cabin that moved. Forestry teams mapping the dense Siberian taiga near Tinder returned to a clearing they had surveyed months earlier, only to find that the cabin they had catalogued had shifted several meters from its original location. The structure, modest in size and constructed from local pine logs, had been a fixed reference point for mapping crews and logging patrols alike. Its foundation, initially aligned with careful measurements and triangulated against nearby river bends, now appeared subtly displaced, with the surrounding vegetation showing signs of disturbance, as though the earth itself had nudged the building along a quiet, deliberate path. The anomaly immediately caught the attention of surveyors and logging engineers, who meticulously verified coordinates using compasses, measuring tapes and theodolites, each reading confirming the unsettling truth: the cabin had moved. The region around Tinder lies deep within the Siberian taiga, a landscape dominated by dense conifers, larch forests, and thick undergrowth. Soil composition here is a complex layering of humus, sand, and permafrost, the latter reaching depths of several meters in some areas. Seasonal freeze-thaw cycles exert considerable pressure on the ground, causing frost heave that can lift and shift objects over time. Streams and minor rivers thread through the forest, influencing soil moisture and stability, while winter snowpacks, sometimes exceeding 2 meters, add immense weight to any surface structure. Despite these environmental forces, no recorded natural process seemed sufficient to account for the cabin's measured displacement without damaging its timber framework or altering its precise orientation. The cabin itself was modest but sturdy, designed to serve as a shelter for forestry workers and as a point of reference for mapping expeditions. Constructed in the late 1960s, it rested on a simple foundation of horizontally laid logs, with minimal anchoring into the soil, standard for temporary structures in remote Siberian forests. It had been maintained and recorded regularly by Soviet forestry teams, who noted minor repairs to the roof and walls over the years but never observed any significant movement. The structure's stability, combined with its well-documented location, made its sudden relocation all the more baffling to both engineers and surveyors. When the first follow-up team arrived, their instruments confirmed what photographs had already suggested. The cabin had shifted more than 3 meters from its previously recorded coordinates. Snow and frost had left impressions in the surrounding soil that indicated movement, yet there were no signs of machinery, human tampering, or animal interference capable of producing such an effect. Logs and brush around the cabin's perimeter showed subtle compression, consistent with the weight of the building having pressed into the ground during transit, but the structure remained intact, upright, and seemingly unscathed by the movement. Surveyors repeated their measurements multiple times, employing triangulation techniques that eliminated human error, and yet the readings remained consistent, reinforcing the inexplicable nature of the phenomenon. Soviet-era forestry logs meticulously documented each anomaly. Officers recorded the original position of the cabin with coordinates marked against nearby rivers, hills, and forested ridges, then detailed the measurements after the shift had been confirmed. Photographs accompanied the entries, showing the cabin from multiple angles, with shadows of trees and surrounding markers providing scale and context. Analysts noted the uniformity of the movement. The building had shifted in a straight trajectory across the clearing, maintaining its alignment relative to the surrounding forest rather than tilting or twisting, which would have been expected if natural subsidence or soil creep were solely responsible. Environmental and geological experts proposed several potential explanations. Frost heave, resulting from the expansion of ice in permafrost layers, can lift and shift heavy objects, but this process typically produces uneven movement and would likely damage a wooden structure of this size. Soil creep, the slow downhill movement of saturated ground, also seemed insufficient, given the minimal slope of the clearing and the uniformity of the displacement. Some engineers speculated about the possibility of underground water flows exerting pressure beneath the foundation, yet no streams, springs, or other hydrological anomalies were observed in the immediate area. Each hypothesis offered partial insight but ultimately fell short of providing a complete explanation. Subsequent inspections revealed further irregularities. Teams noted subtle tilting of the cabin, slight compressions in the surrounding soil, and small indentations suggesting incremental adjustments over time. These patterns hinted at a gradual, persistent force acting upon the structure, rather than a single sudden shift. Investigators considered seasonal snowpack pressure, but measurements indicated that the weight of accumulated snow alone could not account for the distance travelled. Surveyors also ruled out mechanical interference, as the remote location made vehicular access nearly impossible, and no evidence suggested human intervention. Soil analysis around the cabin revealed unusual compaction patterns beneath the structure. Core samples taken along the trajectory of movement indicated alternating layers of frozen and semi-thawed humus that appeared denser than surrounding areas, suggesting that seasonal freeze-thaw cycles may have produced microscopic shifts in soil density. These variations, however, were insufficient to explain the cabin's entire displacement, and no subterranean channels or water flows were detected that could generate lateral force. Yet the pattern of compression hinted at a subtle, persistent influence beneath the surface, as if the forest floor itself had been quietly guiding the cabin along a path determined by forces beyond immediate observation. The difficulty of continuous observation compounded the mystery. The Siberian winters were harsh, with temperatures plunging below -40°C, limiting the possibility of year-round monitoring. Dense undergrowth, uneven terrain, and unpredictable river crossings made repeated field visits challenging, leaving researchers dependent on sporadic, highly detailed measurements. Each expedition, however, consistently recorded the cabin's new location, confirming that its movement was neither random nor the result of observational error. Decades of logging records, geotechnical analysis, and environmental study failed to uncover a definitive cause. The cabin's silent migration continued to challenge assumptions about forest dynamics, permafrost behaviour, and structural stability in extreme climates. Engineers, foresters, and geologists alike recognized that the anomaly did not conform to any known processes, leaving the structure as a fixed yet mobile witness to forces that remain largely unquantified. Its journey, slow and deliberate, persisted through the dense taiga, resisting explanation despite every tool at the investigators' disposal. The cabin waits in its new clearing, unmoved by human hands, yet quietly insisting that the forest has its own hidden rhythm. The Vitim River glow beneath the ice. Winter patrols along the Vitim River noticed a faint green light shimmering through the thick ice, a glow that cut across the frozen channel with an intensity that seemed impossible for such a remote, uninhabited stretch of Siberia. The phenomenon first caught the attention of Soviet telecom teams tasked with checking ice thickness and signal lines, who paused in disbelief as the illumination pulsed subtly under the frozen water. Survey logs from those expeditions noted the glow appearing along stretches of river several kilometers in length, sometimes spreading across wide swaths of ice, sometimes confined to narrow channels near river bends. No surface disturbance accompanied it, no ripples, no shifting snow, no wind to explain the motion, and yet the light persisted in repeated observations, resisting every attempt to locate its source. The Vitim River, a tributary of the Lena, cuts a deep corridor through the Siberian taiga, flowing over hundreds of kilometers of ice and snow during the winter months. Its waters, normally dark and opaque during summer, take on a subdued, muted hue once frozen over, as sheets of ice often exceed 1 meter in thickness in central Siberia. Seasonal snowpacks cover the banks and the river itself, sometimes exceeding 2 meters in accumulation, while low winter sun angles cast long shadows across the surface. Survey teams navigating this terrain contend with temperatures that regularly plunge below -40 degrees Celsius, and short daylight hours limit direct observation. Yet despite these harsh conditions, the glow persisted across multiple seasons, noted independently by separate teams who recorded identical anomalies in the same stretches of river. The light was described by observers as soft, almost ethereal, with a green hue that seemed to ripple and flow in tandem with hidden currents. It appeared as if the frozen river were breathing from below, a quiet pulse visible through the ice. Surveyors attempted to photograph the phenomenon, but camera film often failed to capture the subtleties of the illumination, resulting in only faint traces or blurred patches. Logs recount that workers would pause, watching as the glow shifted gently along the flow, sometimes splitting into parallel strands or disappearing altogether, only to re-emerge moments later. One entry notes, "The light moves with the current, yet there is no disturbance, no reflection, and no discernible source in the water above or on the banks." Ice conditions in the Vitim River are complex. Multiple layers form as meltwater refreezes over existing sheets, interspersed with pockets of trapped air and sediment. These layers can bend and scatter light, creating patterns that might appear luminous to the observer. Subsurface currents continue to flow, sometimes swiftly, sometimes in eddies that twist and turn hidden beneath the frozen surface. Despite these environmental factors, the observed green hue remained consistent, appearing in areas where the ice was thickest and most opaque, ruling out simple reflection or refraction as a sufficient explanation. The ice itself seemed to act as both a barrier and a lens, holding the light in place while allowing it to shimmer just enough to capture human attention. Detailed field logs from repeated expeditions provide the only reliable documentation of the phenomenon. Teams measured ice thickness, recorded the exact locations of each sighting, and noted weather and snow conditions. Equipment included flashlights, cameras, and occasionally hydrophones to detect any vibrations or currents in the water. Every report described the same key details. The green glow appeared without warning, persisted for variable lengths of time, and faded silently, leaving the ice seemingly unchanged. Observers confirmed the absence of wind, precipitation, or other surface effects that could have produced the visual anomaly, reinforcing the conclusion that the light originated from the water itself, or something closely associated with it. Several hypotheses emerged from the work of scientists and surveyors. Some suggested chemical luminescence, perhaps from trapped gases such as methane interacting with cold water under the ice. Others considered bioluminescent organisms, which might survive in the river's frigid depths and emit light during periods of low activity. Optical effects caused by layered ice, refraction, or trapped air bubbles were also explored. Each theory, however, faced challenges. Methane emission could not account for the steady, flowing patterns observed. Bioluminescence in rivers this cold is rare and typically dim. Optical anomalies would not consistently produce the green coloration across multiple seasons. No single explanation sufficed to account for the intensity, hue, and subtle motion documented by patrols. By conducting repeated surveys, researchers identified patterns in the glow's appearance. Certain river stretches seemed prone to illumination, while others remained dark. Observers noted that the glow often followed the invisible currents, drifting in elongated, sinuous forms. In some cases, it split into strands, tracing paths that mirrored the contours of the riverbed, as though tracking hidden channels under the ice. These observations, documented over the years, indicated a consistency that suggested a force or phenomenon operating with regularity rather than random chance. Despite the attempts to quantify it, the behaviour remained unpredictable in timing, duration and exact location. Harsh winter conditions in Siberia made sustained observation nearly impossible. Sub-zero temperatures, thick snow cover, and dangerous river conditions limited teams to short inspections. Continuous monitoring was nearly impossible, and most measurements relied on intermittent field visits, often spaced weeks apart. Yet each report from these expeditions corroborated the previous observations, confirming the green luminescence as a genuine and repeatable occurrence. The ice itself, while thick and opaque, acted as both medium and barrier, creating a unique window into a phenomenon that could not be experienced under any other conditions. The glow's origin remains unresolved, even after decades of meticulous documentation and scientific study. Each hypothesis, chemical, biological, or optical, fails to fully explain the consistent appearance, the subtle drifting, and the precise hue noted in the logs. The phenomenon continues to puzzle scientists, surveyors, and explorers, a rare reminder that even in one of the most thoroughly studied regions of Siberia, nature can still produce phenomena that resist understanding. The Vitim River glows silently through the ice, a quiet signal of something that moves where no eyes can follow. The Yamal Peninsula Thunder Ridge pattern. A low, rolling pulse repeated itself at precise intervals, each concussive note echoing through the cold Siberian air, measurable and unyielding, as if an unseen metronome marked the passage of time. There was no thundercloud, no wind to carry sound across the tundra, no precipitation to trigger the vibrations. Yet the pulses persisted, unfolding in a rhythm so consistent that they could almost be counted, seconds stretching and contracting only to align again with perfect precision. Those who first noted it described a sense of order imposed upon an otherwise still and frozen landscape, an invisible hand moving with deliberate care. Each vibration was brief, a deep rumble resonating over miles, then fading just enough to leave anticipation before the next. Minutes passed between each sound, and the intervals were consistent enough to draw attention from geophysicists and remote monitoring stations alike. The pulse was not loud in the conventional sense. It did not snap or crack, but instead rolled through the air and soil, a low-frequency resonance that seemed to vibrate both earth and mind. Instruments detected the signal at considerable distances, confirming what human ears alone could scarcely comprehend. The sound was measurable, repeatable, and defied conventional explanation. Every sequence recorded over hours, days, and weeks demonstrated the same pattern, rolling, timed, unbroken, a rhythm that might have belonged to some colossal mechanism hidden from sight. It was only when the vibrations were recorded on sensitive seismographs and infrasound microphones that human presence fully acknowledged what had already existed in the quiet tundra. Operators at distant research stations began to compare notes, and patterns emerged that were impossible to ignore. Each pulse registered as a low-frequency wave capable of travelling dozens of kilometres across frozen soil, yet no corresponding seismic event was recorded in the known tectonic network. Atmospheric measurements were equally unremarkable: clear skies, low wind speeds, and no anomalies in air pressure. The sound seemed to exist independently of weather, independent of human activity, as if it had its own schedule. Analysis revealed qualities that made the pulses even more confounding. Their timing was precise, spaced evenly across the hours, and yet occasionally shifting in ways too subtle to detect without instrumentation. The vibration's amplitude remained consistent, unaffected by temperature fluctuations or snow accumulation. Even in locations hundreds of kilometers apart, simultaneous recordings showed near-identical patterns. Attempts to trace the origin through triangulation yielded only vague approximations. The pulses seemed to radiate in multiple directions at once, slipping through the tundra like liquid sound. All known geophysical mechanisms were taken into account by scientists. Could permafrost cracking produce such a regular series of vibrations? Perhaps, but natural permafrost tremors are sporadic, unpredictable, and often localized, none of which match the measured intervals of these pulses. Methane release from thawing soil might produce sound, yet the phenomenon occurred even in areas where the ground remained completely frozen. Distant seismic activity could carry vibrations across long distances, but no tectonic events coincided with the regularity of the pulses, and their measured frequencies fell outside normal earthquake ranges. Even human-made or industrial causes were ruled out, as there were no operations capable of producing such low-frequency sounds in the remote peninsula. Advanced geophysical surveys attempted to detect any subsurface cause for the pulses. Ground-penetrating radar, magnetometers, and electrical resistivity probes were deployed across the ridge to identify anomalies beneath the frozen surface. Slight variations in magnetic field intensity were recorded at certain points along the tundra, yet these fluctuations were inconsistent with known mineral deposits or tectonic features. Soil cores revealed permafrost layers of uniform composition, and no unusual metallic inclusions or voids were detected that might channel vibrations. Even the most sensitive seismometers positioned directly above the suspected source registered no corresponding tremor, reinforcing the notion that the pulses originated from a mechanism or phenomenon entirely invisible and undetectable by conventional instruments, leaving researchers to question whether the source was physical, atmospheric, or something not yet conceived by modern science. A strange psychological effect was described by observers who experienced the pulses. The vibrations were felt in the chest and feet as much as heard in the ears, a subtle yet pervasive awareness that something beyond comprehension was at work. The rhythmic nature lent the sound a sense of intention, a heartbeat that seemed to mark the passage of time across a vast and empty land. For those stationed in temporary field camps, the effect could be disorienting. Hours stretched with the beat of the concussions, and the silent intervals between them seemed heavier than the pulses themselves. Weeks, months, and even years of repeated monitoring confirmed the anomaly's persistence. Logs documented dozens of sequences, each occurring at precise times, sometimes at different points along the tundra's expanse, as if the pulses were travelling or following an unseen pathway. The phenomenon persisted across seasons, appearing in the dead of winter when snow blanketed the plains and ice-covered rivers, and again in early spring when melting streams revealed the frozen soil below. Its presence was independent of natural cycles, yet consistent enough to imply a pattern too deliberate to be entirely random. In the pursuit of explanation, researchers examined the interplay between the pulses and the tundra itself. Low-frequency sound can travel farther over frozen surfaces than over open soil or vegetation, and the peninsula's flat topography may have allowed vibrations to propagate with minimal loss of energy. Yet even this environmental factor fails to explain the anomaly's timing and reproducibility, which surpassed all known natural acoustic phenomena. Instruments captured the concussions with exacting precision, yet the cause remained elusive, the origin hidden in a realm inaccessible to measurement or direct observation. For locals and scientists alike, the pulses became a strange companion to the peninsula, a persistent, measured phenomenon that reminded them of the unseen complexity of the Arctic wilderness. The anomaly's very regularity made it unsettling. It suggested design, or at least order, in a landscape that seemed otherwise empty and unchanging. No instrument, no theory, and no explanation could fully reconcile the sound with the known principles of physics or geology. The mystery endured, recorded in logs, etched into memory, and carried across the frozen expanse with every measured pulse. The thunder-like pattern continues to ripple across the frozen Yamal, a measured heartbeat that no one can trace, yet everyone can feel. The Buryatia lakebed carvings. When the waters of a remote Buryatia lake receded unusually far during a dry season, the exposed bed revealed a series of deep geometric etchings, stretching across silty flats with a precision that immediately drew attention. The carvings were not subtle impressions or natural cracks. They followed sharp, deliberate lines, forming shapes that suggested careful planning and execution. No current or frost pattern could account for their straight edges, and the depth of each groove indicated sustained effort rather than accidental formation. Scientists and locals alike were struck by the sudden emergence of what seemed like a hidden layer of history, revealed only when the lake yielded its secrets under the weight of low water. The lake itself rests in a quiet basin, encircled by pine-clad hills and low mountains that feed it with narrow and flowing streams. In summer, these streams swell with melted snow and rain, returning the lake to near full capacity, while in late summer and fall evaporation and reduced inflow leave stretches of mud and sediment exposed. Typical seasonal fluctuation uncovers only shallow patches of the floor, but in particularly dry years, large expanses become accessible, as if the lake were intentionally opening a window to the past. The basin's silty soil preserves impressions far better than sand or coarse gravel, providing an unexpected canvas for what now appears to be a complex series of carvings. Examining the exposed lakebed, researchers noted that the etchings followed geometric principles, with lines extending over several meters, intersecting at consistent angles, and forming patterns that suggested deliberate design rather than random erosion. Some grooves were wide and deep enough to be traced by hand, while others formed fine lines that shimmered in the sun as shallow troughs across the mud. The interplay of depth and width created shadows that accentuated the carving's complexity, making their shapes visible even from a distance. Each line appeared to have been executed with care, without deviations or signs of hasty creation, hinting at a sophistication not typically associated with the region's documented historical activity. When scientific teams arrived to document the phenomenon, they approached the lakebed with caution and precision. Photographs, sketches, and measurements were taken, with survey markers placed along the carvings to map their layout accurately. Early sonar attempts and shallow core samples confirmed that the carvings extended beneath the surface sediment, preserved under layers of silt accumulated over decades of submersion. Logs and notebooks filled with meticulous drawings captured the angles and intersections, creating a visual record that could be studied long after the water returned. Researchers remarked on the unexpected scale of the patterns, some extending dozens of meters across the exposed flats, forming networks whose full purpose remained enigmatic. The geological and hydrological characteristics of the lake provided insight into why the carvings had survived. Fine silt and periodic sediment deposition acted as a protective layer, preserving the grooves despite decades underwater. Seasonal drying cycles exposed the bed only briefly, limiting the erosive effects of wind or water movement. In areas where frost penetrated the soil, shallow fractures ran near the carvings, but they did not alter the shapes significantly, allowing the original patterns to remain largely intact. The combination of preservation and exposure created rare opportunities for study, with each low water season revealing the carvings anew, unchanged, and waiting for human observation. Closer inspection of the exposed flats revealed subtle microtopographical features that may have contributed to the carving's preservation. Tiny ridges and depressions in the silt appeared to channel water during seasonal inflows, directing gentle flows away from the etched lines and preventing scouring of the deeper grooves. In areas where inflow streams temporarily widened, thin layers of fine sediment settled evenly, filling minor irregularities but leaving the main patterns intact. The surface also displayed traces of microbial mats, common in still or slow-moving waters, which could have formed a thin protective film over the carvings during prolonged submersion. These minute natural defences, combined with the lake's periodic exposure, created conditions that allowed intricate human, or possibly unknown, interventions to survive with remarkable clarity, offering an unexpected glimpse into a layer of history otherwise hidden beneath decades of water and sediment. Speculation about the carving's origins quickly arose. Could they have been made by early nomadic peoples, a ritualistic marking long forgotten? Perhaps some unknown group with advanced skills once traversed the region, leaving these signs for reasons now lost to time. No artifacts, pottery shards, or structural remains were found nearby to corroborate human activity, leaving the patterns isolated in both space and history. Yet the precision and scale suggested intentional creation, as if someone had deliberately chosen this lakebed as a canvas for a message, map, or symbolic display. Analytical attempts to date the carvings proved difficult. Submersion under decades of water prevented conventional radiocarbon sampling of the grooves themselves. Sediment layers offered some context, suggesting that the carvings predated the most recent century of fluctuating water levels, but this provided only a rough estimate. Comparisons to other known sites in the region revealed no parallels. The shapes did not match petroglyphs, burial markers, or other documented human-made carvings from Buryatia or neighbouring Siberian regions. Their isolation and uniqueness added to the sense of mystery surrounding them. Repeated observation each season revealed subtle changes caused by sediment shift, minor erosion, or compaction, but the fundamental patterns remained unchanged. Each time the water receded, the carvings re-emerged as sharply defined as before, an enduring record of something lost to memory. Teams photographing the bed over successive years noted consistent alignment with cardinal directions and local topography, though whether this was intentional or coincidental remained unresolved. Scholars debated the potential significance of the geometric forms, but every hypothesis encountered the same obstacle: the absence of context, artifacts, or historical records to explain the carving's origin. The lakebed became a place of quiet fascination, drawing both scientists and locals who walked carefully along the silt, tracing lines with fingers or simply observing the arrangement of intersecting grooves. There was a sense of awe in seeing something so deliberate and enduring appear only under fleeting conditions, a momentary revelation from a lake that otherwise kept its past submerged. The carvings felt like messages from a distant time, offering no answers but prompting countless questions about who might have made them, why, and how they were preserved so perfectly. The etchings wait quietly beneath returning waters, their lines preserved in silt, whispering of a knowledge no one has yet unravelled. The Altai echo that answered incorrectly. In the steep valleys of the Altai Mountains, sound typically behaved predictably, bouncing off cliffs and ridges in measured intervals, returning each shout or signal in the rhythm expected by both nature and human calculation. Survey teams relied on these echoes to gauge distances, communicate across ravines and map the terrain, assuming that rock faces and air density would dictate the path and timing of any returning sound. Yet during one expedition, the expected patterns began to unravel. Echoes returned not from the cliffs they had originated from, but from directions that made no apparent sense, sometimes delayed by fractions of seconds, sometimes arriving astonishingly early, as if the canyon itself had reshaped the rules of sound. Observers paused, recalibrating watches and compasses, only to find the results repeated with relentless consistency. The canyon in question was carved over millennia by the slow flow of the Putana River, its walls towering hundreds of meters above the riverbed, alternating between smooth granite faces and fractured outcrops. The valley's orientation funneled winds at variable speeds, while temperature gradients between sunlit ridges and shaded floors created pockets of still air. Normally, these conditions merely coloured the timber or slightly altered the velocity of returning echoes. Here, however, the echoes ignored all expectations, arriving from angles that instruments could not trace, suggesting a phenomenon entirely detached from conventional acoustics. While engaged in standard mapping exercises, surveyors first observed the anomaly. Using hand signals and measured shouts, they timed the interval until the sound returned. In one test, a signal expected to bounce back from a granite wall located 400 meters away returned in a time corresponding to a distance of over half a kilometer, and in another case the return arrived too soon, implying that the echo had traversed a distance that defied physics. The teams repeated these tests under varying conditions, different times of day, varying temperatures, even with portable acoustic amplifiers, but the results remained consistent. The canyon's echoes seemed to answer incorrectly. Instruments corroborated human perception. Microphones and analog timing devices registered the same irregularities, confirming that observers were not misjudging intervals. The pulses of sound arrived from unexpected trajectories, sometimes appearing to bend around corners or reflect from surfaces that should have been acoustically irrelevant. Attempts to model the canyon's acoustic properties revealed no feasible explanation. The rock formations, when analysed with precision topographical data, could not account for the repeated divergence from predicted echo paths. The anomaly was measurable, reproducible, and utterly inexplicable. Acoustic experts arrived to examine the canyon in detail. They measured air density, wind speeds, humidity, and thermal gradients, even testing the effects of snow cover and river flow on sound propagation. While minor distortions could be explained by stratified air layers or reflective surfaces, these accounted for only a fraction of the deviations. Some echoes appeared to travel along curved paths, yet no such channels existed in the topography, and temperature differentials were insufficient to create significant refraction at audible frequencies. Every plausible natural explanation fell short of accounting for the magnitude and precision of the anomalies. Detailed geological surveys revealed subtle variations in the mineral composition of the canyon walls that might influence sound propagation. Sections of granite alternated with veins of schist and mica-rich rock, creating interfaces with slightly differing densities and elastic properties. Ground-penetrating radar indicated minor subsurface fissures, some filled with compacted sediment and others air-filled, which could produce localized reflections or refractions of sound waves. While these features were far too small to account for the full magnitude of the echo anomalies, their presence offered a plausible mechanism for some of the unexpected scattering and slight bending of sound observed during field tests. Surveyors noted that these geological subtleties, combined with seasonal shifts in snow cover and soil moisture, could produce ephemeral variations in acoustic pathways, adding layers of complexity to an already confounding phenomenon. The way humans experienced the echo introduced an additional layer of intrigue. Observers reported a subtle disorientation, a feeling that the canyon was responding with intention, almost as if it were aware of the sounds it received. Shouts and claps returned altered in timing and direction, sometimes louder, sometimes softer, creating a dissonance between expectation and experience. Some surveyors noted that prolonged exposure led to a heightened awareness of the environment, as if the canyon's unusual responses demanded careful attention, fostering both awe and unease. Over the course of several surveys spanning different seasons, the anomaly endured. Summer expeditions recorded echoes under clear skies and stable temperatures. Winter teams confirmed similar irregularities when snow blanketed the valley and the air was denser. Each observation confirmed the anomaly's reproducibility. The echoes consistently failed to conform to calculations grounded in known physical laws. Even minor variations in temperature, humidity, or river noise could not account for the persistent deviations, reinforcing the sense that this was a phenomenon entirely outside conventional understanding. In their investigation, researchers explored multiple theoretical possibilities. Could hidden fissures or underground channels bend sound unpredictably? Perhaps the composition of granite and sediment created natural acoustic lenses? Or might temperature inversions in the valley's microclimate act as a refraction system for sound waves? Each hypothesis provided a partial explanation, but ultimately failed to account for the precision and consistency observed. No combination of factors could replicate the exact intervals, angles, and alterations recorded over multiple expeditions. The anomaly became both a scientific puzzle and a psychological curiosity. Observers found themselves testing theories with shouts, claps, and percussion instruments, only to be confronted by the canyon's defiance of expectation. The echoes, returning incorrectly yet consistently, challenged the assumption that nature adhered strictly to measurable rules. It was as if the mountains were conducting experiments of their own, presenting data that humans could record but not fully interpret. Multiple survey logs now document the phenomenon, with charts showing return times, angles, and anomalies relative to expected acoustic behavior. Each dataset reinforces the inexplicable nature of the canyon's responses. Scientists continue to speculate about hidden geological formations, unusual air currents, or as yet undiscovered physical effects, yet none offer a definitive explanation. The anomaly persists, a reminder that even the most measured and predictable forces of nature can harbour mysteries beyond comprehension. The canyon continues to return echoes that should not exist, as if the mountains themselves are answering questions no one has asked. The Tomsk Marsh Iron Poles. Geologists mapping the wetlands near Tomsk first encountered the poles unexpectedly, their rigid forms jutting from the marsh as if deliberately planted yet entirely unexplained. The iron posts, standing upright in the saturated soil, were perfectly cylindrical and evenly spaced across several hundred meters of boggy terrain, drawing immediate attention from surveyors unaccustomed to such precise objects emerging from the waterlogged ground. No remnants of construction, logging, or industrial activity were evident, and the surrounding marsh bore no signs of human alteration beyond customary footpaths and the occasional survey marker. Each post's consistency, its height, diameter, and position immediately suggested intentional placement, yet its presence in this remote and largely inaccessible marsh rendered any conventional explanation impossible. The Tomsk Marsh itself is an expansive wetland of peat and clay, punctuated by shallow pools and dense sedge growth. Water levels fluctuate seasonally, swelling during spring thaws and receding gradually through late summer, exposing stretches of soft, malleable soil interspersed with moss-covered hummocks. The region experiences long winters, with surface water freezing to depths that can exceed 0.5 meter, yet the marsh's peat retains moisture beneath the ice, providing a continuously saturated environment. These conditions, while natural, make the enduring rigidity of the iron poles all the more remarkable, as the saturated, acidic soil of peatlands typically accelerates metal corrosion, breaking down iron exposed to oxygen and moisture over decades. The poles themselves were striking in appearance. Each rose 2 to 3 meters above the surface, with smooth, unblemished surfaces showing no signs of rust, pitting or flaking. Their tops were flat and many were aligned with near-perfect regularity, forming a rough grid that extended over what appeared to be hundreds of meters of marsh. The spacing between poles varied slightly, but the general pattern suggested deliberate design rather than random emergence or natural metallic veins. Their orientation, largely perpendicular to prevailing wind and water flow, seemed intentionally calculated, as if the posts had been positioned to withstand environmental pressures while maintaining an exacting formation. Meticulous documentation of the anomaly was carried out by survey teams, measuring distances, heights, and alignment angles. Laser rangefinders, measuring tapes and magnetic compasses were employed to create a comprehensive record of their positions. Photographs captured the poles in their seasonal context, showing how they rose above patches of sedge and shallow pools alike. Attempts to core the posts revealed solid iron, with no hollow sections or signs of modern welding techniques, and magnetic tests confirmed uniform composition consistent with ferrous metals, though the exact alloy remained undetermined without laboratory analysis. Additional tests revealed subtle but unusual magnetic readings around several of the poles. Compasses held near the posts occasionally deviated slightly, pointing a few degrees off true north, an effect not observed in nearby areas of the marsh. Surveyors noted that this variation appeared inconsistent, shifting slightly depending on proximity to individual poles, yet always remaining within a detectable range. Water samples collected in the immediate vicinity showed no anomalous metallic content, suggesting that the magnetic irregularities were intrinsic to the poles themselves rather than caused by surrounding sediments. Seasonal temperature changes did not diminish this effect. Readings persisted through both freezing winters and warm summer months, hinting at an enduring property of the iron that further distinguished these posts from ordinary constructions. Chemical and geological considerations deepened the mystery. Peatland water, typically acidic and rich in humic acids, accelerates iron oxidation, yet the poles' surfaces were pristine. Samples of surrounding soil and water indicated pH levels below neutral, temperatures ranging from near freezing in winter to mild in summer, and ample oxygen availability, all factors that should promote rust. Despite this, the poles remained unweathered, suggesting either a form of treatment lost to history or a natural phenomenon that prevented oxidation. Their corrosion resistance, in combination with their unexpected placement, challenged the fundamental understanding of metals exposed to such wetland environments. Historical investigation offered no clarity. Records of industrial activity, logging, or transportation in the immediate marsh area were absent. Local accounts referenced no structures or experiments that could account for the poles, and older maps depicted only the natural wetland terrain, with no indication of iron posts or markers. Archaeologists and historians were unable to connect the anomaly to known human occupation, past engineering projects, or Soviet-era surveying activity. The poles remained isolated, their presence unexplained, existing in a place that had otherwise experienced minimal human intrusion for decades. Their persistence was confirmed over repeated surveys conducted across multiple seasons. In spring, when meltwater expanded across the marsh, the posts remained upright, anchored securely in soil that shifted around them. Summer low water conditions exposed more of their bases, yet inspection revealed no rot or instability. Autumn brought ice formation and frost heaving, but the poles showed no signs of tilting or displacement. This remarkable durability reinforced the impression that these were not ordinary iron objects, and that the marsh, despite its harsh and shifting environment, had preserved them in an almost unnatural state. Hypotheses emerged to explain their existence. Some suggested they were remnants of a long-forgotten experimental installation, perhaps for measuring marsh hydrology or soil stability, yet the complete absence of records made verification impossible. Others proposed that ancient peoples may have used iron posts for unknown ceremonial or navigational purposes, though the sheer regularity and spacing argued against a primitive construction. Geological explanations were considered, including natural metallic concretions rising from the subsoil, yet the precision and uniformity of the poles seemed incompatible with purely natural formation. Each theory encountered a wall of inconsistency, leaving the poles as a tangible enigma resistant to explanation. The human response to the poles was as notable as the anomaly itself. Surveyors described a quiet unease at their unexpected upright presence, a sense that the marsh had been shaped by hands or forces unknown to history. Walking among them, one could sense a deliberate order, a grid that suggested purpose yet offered no guidance or message. Observers noted the contrast between the marsh's soft, yielding earth and the rigid, steadfast poles, creating an almost surreal tension between expectation and reality. For now, the Tomsk Marsh iron poles stand as a silent puzzle, their very presence in the saturated peat defying both natural and human explanation. No archival research, geochemical test, or observational survey has yet accounted for the combination of their placement, preservation, and scale. The iron posts remain anchored in shifting peat, hinting at a presence that no record, theory, or science has yet explained. The Sayan Pass temperature divide. As the expedition climbed the winding path through the Sayan Pass, one member noticed a sudden shift in sensation. On the left side of the trail, the air felt sharp and frigid, biting through gloves and jackets, while only a few paces to the right, the atmosphere was unexpectedly warm, almost soft against exposed skin. At first, the change was attributed to sun exposure or wind patterns, yet repeated steps across the divide confirmed its persistence. Thermometers drawn from packs displayed the same discrepancy. Temperatures differed by several degrees over a span scarcely a metre wide. Snowflakes that clung stubbornly to rocks and branches on one side melted almost instantly. A step over, and frost on mossy patches disappeared with equal abruptness. The team realised they had encountered what would later be recorded as the Sayan Pass temperature divide, a sharply defined corridor where cold and warm air met with an abruptness that seemed impossible in a natural mountain setting. The pass itself stretches between craggy ridges and narrow valleys, alternating between rocky outcrops and dense forested slopes. Sunlight strikes the terrain unevenly, with some ridges catching the morning glow while deep hollows remain in shadow, creating microclimates across remarkably short distances. Snow cover, when present, reflects light and retains cold, while exposed rock absorbs heat, complicating the thermal dynamics of the area. Vegetation ranges from spruce and pine to moss and lichens, their surfaces visibly reacting to the abrupt temperature differences, with frost clinging to the cold side and dewdrops forming on the warmer moss just steps away. Even small birds and rodents seem to prefer the warmer corridor, leaving the colder side nearly undisturbed, as though instinctively responding to the invisible boundary. Meteorological teams first documented the anomaly with meticulous care. Thermometers, hygrometers, and portable anemometers were used to measure the air along the trail, while soil probes recorded temperature changes beneath the surface. Each instrument confirmed the phenomenon, a nearly vertical shift in temperature over a horizontal distance of less than a metre, repeated along a segment of the pass several kilometres long. Ice crystals and frost on the cold side maintained their structure, while the adjacent warm zone revealed softening ground and early signs of snowmelt. Even small streams that crossed the divide exhibited subtle differences in surface temperature, remaining partly frozen on the cold side while trickling freely on the warmer side. Further observations revealed the divide's consistency under varying weather conditions. During calm, clear mornings, the transition was sharp and unyielding, and during gusting winds the boundary persisted, as if invisible barriers channeled the air into separate domains. Soil thermometers registered the same sudden shifts, with permafrost near the cold side remaining hard and icy, while the warmer side showed signs of early thaw, despite both areas receiving identical sunlight and wind exposure. The frost line appeared to follow the divide almost precisely, leaving vegetation and ground litter partially coated on one side and exposed on the other, a pattern repeated across several hundred meters of the pass. Seasonal investigations deepened the mystery. Spring thaw revealed melting streams that ran along the divide without mixing across it, and summer measurements confirmed the persistence of the boundary even as ambient temperatures climbed. In autumn, frost returned abruptly on one side, while the other remained surprisingly mild. Winter expeditions noted ice forming on the cold side, while snow partially melted a mere step away, hinting at a sustained and localized thermal influence that could not be accounted for by ordinary topography, solar exposure, or wind patterns. Even brief fogs seemed to separate, curling over the cold side while leaving the warmer zone clear, enhancing the sense of a physical partition drawn in the air itself. Scientists explored a variety of explanations, considering cold air drainage along ridges, temperature inversion layers, subtle variations in solar heating, and the effect of differing soil moisture and permafrost distribution. Hypotheses involving geothermal flux or subsurface water channels were examined, as were the possibilities of rare atmospheric density shifts or localized wind eddies. Yet the extreme sharpness and reproducibility of the divide contradicted conventional models. Airflow simulations suggested that minor obstructions or slopes might create temperature variation over tens of meters, but nothing could reproduce the near-instantaneous change occurring over a single step. The human experience of crossing the divide was equally extraordinary. Expedition members described the sensation as stepping between two different worlds, feeling the air itself change character. Frost clung to the tips of branches and blades of grass on the cold side, while mosses and ground cover on the warmer side appeared more vibrant and pliant. Even the sounds of movement differed, with ice-crusted soil producing sharper crunches in the cold zone, while wet earth muffled footsteps on the warm side. Small animals appeared to instinctively avoid the cold corridor, creating a sense of isolation and quiet in that section of the pass. Researchers noted that prolonged exposure to the colder side caused a rapid chill even with full winter clothing, while the warmer side offered a surprising comfort. Repeated studies and mapping of the area over several years confirmed the anomaly's reproducibility. Teams traced the boundary along its length, marking thermometers at intervals and recording detailed temperature profiles. Despite fluctuations in weather, wind, and sunlight, the temperature shift remained localized and abrupt. This constancy suggested an enduring phenomenon, one that survived daily and seasonal changes and resisted integration into standard microclimatic models. The Sayan Mountains' remoteness, combined with limited historical exploration and sparse human activity in the pass, only heightened the sense of an untouched mystery silently persisting in the wilderness. The Sayan Pass temperature divide challenges assumptions about mountain weather and environmental predictability. Its precise, enduring nature raises questions about the interplay of topography, solar radiation, air density, soil composition, and perhaps hidden hydrological or geothermal forces. Even with modern instrumentation, repeated observation, and detailed analysis, the boundary defies conventional explanation, leaving those who traverse it confronted with the limits of understanding in one of Siberia's most remote and enigmatic landscapes. The cold and warm air remain locked in their invisible boundary, a line drawn by nature with precision that no human hand has yet explained. The Yakutia Forest Vault. After a heavy autumn storm tore through the remote Yakutia forest, surveyors noticed a patch of upturned earth unlike any they had seen before. Among the fallen branches and soil disturbed by wind and rain, a shallow formation of stacked stones emerged, carefully arranged yet partially buried, as if the forest itself had reluctantly revealed the structure. This unexpected discovery would come to be known as the Yakutia Forest Vault. A small chamber of stone concealed within dense conifers, its purpose and origin immediately confounding those who first set eyes upon it. The vault seemed to occupy a precise location in the forest, aligned neither with the nearest creek nor the sun's arc, as though hidden by intent and preserved by the natural processes of decay and growth. The chamber itself was modest in size, barely 2 meters across, but its construction suggested deliberate effort. Stones of varying shapes and sizes had been stacked in an orderly fashion, forming rough walls that enclosed a hollow interior. Some rocks bore shallow grooves, while others were marked by weathered chips that hinted at human handling long ago. The earth surrounding the vault was damp and freshly turned, still carrying the scent of moss and soil churned by the storm. A faint trickle of water ran beneath some of the stones, producing soft, almost musical plinks that echoed within the shallow cavity, lending the site a quiet, unsettling presence that felt at once intimate and enigmatic. The surrounding forest amplified the vault's hidden nature. Thick spruce and larch trees formed dense corridors of shadow, while the ground was blanketed in a layer of fallen needles, moss, and decaying leaves. The permafrost beneath provided a subtle, uneven firmness to the soil, preserving some of the vault's shape while allowing other sections to sink and shift over time. Fallen branches and tufts of undergrowth partially obscured sightlines, giving the impression that the vault had emerged spontaneously, not unlike a geological feature suddenly exposed by erosion. Even the light seemed hesitant, filtering through the canopy in narrow, angled shafts that highlighted certain stones while leaving others in darkness, as though the forest itself had chosen what to reveal. Surveyors documented the site with meticulous care. Measurements of the chamber's dimensions revealed slight asymmetry, yet an underlying geometric logic suggested intentional design. Photographs captured the interplay of shadow and stone, while soil samples indicated layers of compaction differing from the surrounding forest floor. The walls appeared to be carefully positioned to allow water drainage, a practical detail that hinted at thoughtful construction rather than random debris. Still, no artifacts, carvings, or traces of human habitation were found nearby, deepening the mystery of who had built the vault, when, and for what purpose. Within weeks, nature began reclaiming its secret. Rain carried fine soil into gaps between stones, fallen needles, and moss slowly covering the chamber, and the once visible arrangement of rocks grew increasingly obscured. Explorers returning to the site were greeted with partial exposure, the vault now appearing as a low mound in the earth rather than a discernible structure. Even minor winds shifted debris along the edges, and snow that fell in early winter further concealed the chamber beneath a smooth, undisturbed blanket. Each return visit was a reminder that the vault's revelation was temporary, dependent on the intersection of natural forces rather than human preservation. Researchers proposed several explanations, ranging from ritual storage or temporary shelters used by early inhabitants to natural stone arrangements misinterpreted as constructed features. Yet the vault's sudden emergence after a storm, its precise stacking, and the subtle alignment with depressions in the forest floor resisted conventional interpretation. Unlike known archaeological sites, it left no trace in historical maps, logs, or oral histories. Its location was neither near a water source nor along a traditional travel corridor, further perplexing experts who attempted to contextualize it within the broader framework of Siberian exploration and settlement. Repeated expeditions underscored the vault's elusiveness. Teams marked coordinates and returned across seasons, noting shifts in snow cover, soil moisture, and vegetation regrowth, yet the chamber was never fully exposed again. Moss crept across its stones, fallen leaves layered over the interior, and permafrost caused subtle shifts in the wall's alignment. The vault appeared to exist on the border of visibility, accessible for only brief periods before retreating beneath the forest's slow reclamation. Each observation demanded careful measurement and patience, for the structure resisted hurried study, revealing its shape only under the forest's own timetable. Human perception of the vault amplified its mystery. Surveyors described a quiet tension while standing in the clearing. The air was dense with the scent of wet moss and earth, damp and cold from the storm, yet within the hollow of the stones, there seemed a faint difference in temperature and humidity. The trickle of water beneath the stones suggested a subterranean connection, a hidden continuity beyond the shallow chamber. Even birds and small mammals avoided the immediate area, moving cautiously along the edges, as if recognizing an unspoken boundary around a space left intentionally undisturbed. The ephemeral nature of the Yakutia forest vault highlights a recurring theme in the Siberian wilderness. Moments of discovery often coincide with impermanence. Structures, anomalies, and traces of past activity may emerge briefly, only to vanish beneath the relentless reclamation of nature. The vault's sudden visibility, careful construction, and repeated disappearance demonstrate a remarkable interplay between human curiosity and environmental processes. Observers are reminded that some aspects of the natural world remain intentionally hidden, allowing only fleeting glimpses of what lies beneath or beyond ordinary perception. The stones remain buried once more, their order known only to the forest, whispering of a hidden purpose that has eluded every human eye. The Kolpashevo riverbank faces. During a routine survey along the Kolpashevo riverbank, geologists noticed something unusual along a freshly eroded section of clay. Shallow hollows and raised ridges caught their attention, forming shapes that, at first glance, resembled human faces staring out from the river's edge. The formations were not large, each only a few meters across, but their appearance was striking against the reddish-brown clay, particularly under the low afternoon sun, which cast long shadows that seemed to animate the features. The phenomenon would later be recorded as the Kolpashevo riverbank faces, an enigmatic interplay of geology, perception and fleeting exposure, leaving observers uncertain whether they were witnessing natural coincidence or something more deliberate. Closer examination revealed details that both fascinated and unsettled the surveyors. Shallow indentations suggested eyes, small protrusions hinted at noses, and thin ridges formed shapes reminiscent of lips. Yet, upon inspection, it became clear that these faces were entirely sculpted by the river's relentless erosion. Water seeped into the soft clay, slowly carving cavities and ridges, while freeze-thaw cycles during colder nights expanded cracks and shifted soil layers. Tiny droplets of moisture clung to the surfaces, reflecting light in ways that accentuated contours and added an almost uncanny realism to the forms. Even subtle wind gusts played a role, depositing sand and silt in patterns that completed the illusion of features shaped by intention. The surrounding riverbank provided context for this ephemeral spectacle. Layers of clay interspersed with silt and occasional gravel deposits indicated centuries of seasonal flooding, ice scouring and sedimentation. Sparse vegetation clung to higher ground, scraggly shrubs, mosses, and occasional birch saplings rooted in shallow soil. During the spring thaw, the river would rise unpredictably, scouring its banks and exposing fresh clay walls. While in summer, water levels fell, leaving soft surfaces vulnerable to wind and sun. The combination of moisture, temperature fluctuations, and sediment deposition created conditions that allowed the fleeting formation of the human-like shapes, yet only temporarily before the elements reclaimed the surfaces. Beneath the surface, layers of permafrost and seasonal alluvial deposits shifted unpredictably, subtly altering the clay walls and guiding the formation of hollows and ridges that mimic facial features. Repeated thawing and refreezing caused microcracks in the clay, which water soon exploited, carving small depressions and raised lines that, from a distance, suggested eyes, noses and mouths. The Kolpashevo clay itself, a mixture of dense silt, fine sand and sporadic gravel, proved particularly susceptible to this natural sculpting, allowing nearly identical human-like shapes to appear across different sections of the riverbank over multiple seasons. This geological interplay created the illusion of intention within the erosion, giving the fleeting faces a sense of deliberate design that vanished as soon as conditions shifted. Surveyors documented the formations with haste, aware of their transient nature. Cameras and sketches captured faces that appeared and disappeared within hours, as subtle shifts in water or wind altered the contours. Some faces emerged fully in shadow, their eyes hollow and dark, while others formed under direct sunlight, revealing smoother surfaces and softer impressions. No two appearances were identical, yet the human-like qualities were repeated along various stretches of the riverbank, suggesting a pattern produced by the river's natural processes rather than by random chance. Despite the scientific explanations, the psychological effect on observers was undeniable. Standing before the clay walls, surveyors felt a quiet unease, a subtle tension amplified by the uncanny familiarity of the shapes. The human brain naturally seeks patterns, particularly faces, and the sudden recognition of eye-like hollows and nose-like ridges evoked both curiosity and caution. Local folklore lent further weight to the experience. Legends of spirits inhabiting riverbanks or leaving traces in mud and clay added an intangible layer of cultural resonance, though no direct connection was documented historically. The temporal nature of the faces only intensified their mystery. Within hours of observation, minor rain or wind would smooth the clay, erasing delicate ridges, filling hollows with silt, and leaving behind an unremarkable stretch of bank. By the following day, most visible traces were gone, the illusion of faces reduced to random depressions and ridges once again indistinguishable from ordinary erosion. Observers often returned along the same coordinates to find only subtle remnants, a reminder of the river's constant reshaping and the fleeting opportunity to witness the phenomenon. Small mammals and birds often skirted the freshly exposed faces, their movements hinting at a silent acknowledgement of the temporary shapes in the clay. Hares leapt along the edges, leaving tracks that skirted depressions, while riverbank birds, sparrows and wagtails landed on higher ridges, their delicate claws brushing past the hollows without disturbing them. Occasionally, the subtle activity of these animals shifted tiny fragments of silt, slightly altering the contours of the faces, yet never fully erasing the uncanny impressions before the river and wind claimed them. Observers began to note that this quiet coexistence between wildlife and the ephemeral formations heightened the sense that the faces were part of a living, breathing landscape rather than a mere coincidence. Geologists and hydrologists proposed several mechanisms for the recurring shapes. Water erosion, sediment deposition, and freeze-thaw cycles were the primary contributors, while soil composition and microclimate conditions influenced how clearly features emerged. Permafrost beneath the surface occasionally restricted deeper shifts, causing the clay to crack in precise, repeating patterns that favoured the formation of recognisable shapes. Seasonal flood levels determined the length and location of exposed walls, explaining why some appearances were limited to narrow sections, while others stretched for dozens of metres along the bank. Yet the repeated emergence of distinctly human-like forms along multiple sections of the river continued to surprise researchers, as purely random erosion rarely produces such specific illusions. Repeated observations confirmed the persistence of the phenomenon across seasons. Teams returned during spring, summer and autumn, documenting the rise and fall of water, the shifting clay layers, and the temporary appearance of the faces. Lighting conditions influenced perception dramatically. Early morning sunlight elongated shadows, giving depth to indentations, while overcast skies flattened features, making them appear indistinct. Even subtle changes in observer position altered the clarity of the shapes, emphasizing how human perception and natural formation intersected to create the compelling fleeting images. The Kolpashevo riverbank faces stand as an enduring reminder of the wilderness's capacity for subtle deception. Their emergence depends on the interplay of river dynamics, soil properties, seasonal variation, and human perception, and yet they retain an unsettling resemblance to deliberate creation. For those who witness them, the experience combines awe, unease, and a lingering question of whether nature has simply produced a remarkable coincidence or if something more profound lies behind the ephemeral impressions. The faces vanish with the next tide, yet their fleeting gaze lingers in memory, hinting at secrets the river keeps beneath its shifting clay. The Ust-Kut midnight thunderclap. Just past midnight, radio logs recorded a single explosive sound that rolled across the frozen forest surrounding Ust-Kut, startling crews who knew the skies were clear and the winds calm. It was not the sound of conventional thunder, nor the low rumble of distant engines, but something sharper, deeper, and impossibly resonant, carrying across the tundra as though the very air itself had fractured. Aviation teams on routine night patrols reported simultaneous reverberations in multiple sectors, noting that the explosive boom seemed both immediate and endlessly travelling, a sonic presence without a visible source. The incident would later enter official logs simply as the Ust-Kut midnight thunderclap, an event documented with precision yet defying any clear explanation. Voices crackled over radio channels, describing a sound that seemed impossible in both scale and clarity. Operators struggled to reconcile their instruments with their own ears. "It's everywhere at once," one pilot noted, "and nowhere at all." Ground crews stationed near small rivers and frozen clearings reported windows rattling and tents vibrating with the intensity of the boom, yet no meteorological or seismic data offered a hint of explanation. The abruptness left a lingering disorientation. Crews found themselves pausing in the stillness of the Siberian night, listening for a repeat that never came. The geography of the region only amplified the strangeness of the phenomenon. Ust-Kut sits amid dense coniferous forests, larch and spruce stretching uninterrupted across the snow-bound landscape, with frozen rivers weaving through the valleys. Any sound generated locally should have been absorbed or distorted by the terrain, yet the boom propagated with remarkable clarity. Calm winter temperatures and near-zero wind meant that no atmospheric turbulence could account for the rapid, far-reaching travel of the sound. The vastness of the wilderness lent both scale and isolation, turning the auditory event into a surreal experience for all who heard it. Meteorological instruments confirmed a night devoid of storms, and seismographs detected no tremors or ground disturbances. Radar picked up nothing unusual overhead, It was as if the land, the air, and the instruments themselves had conspired to allow a sound to exist outside conventional explanation. Observers noted that the boom arrived in waves, rolling across valleys and ridges without loss of intensity, leaving a sense of suspended disbelief. Each recorded occurrence on the logs matched human testimony, yet offered no traceable origin. Analysts later studied the sound in detail, describing its multitonal resonance and unusual frequency patterns. Unlike thunder or man-made explosions, the boom produced overtones that stretched unnaturally across the frozen landscape, carrying with clarity over tens of kilometers. The first overtone suggested a deep, almost subterranean origin, while higher tones seemed to scatter across treetops and icy rivers. Its auditory signature puzzled experts, who found no precedent for a single instantaneous sound with such widespread and persistent propagation. Subtle shifts in the temperature profile of the Siberian night air may have amplified the sound in unexpected ways, creating pockets where the boom seemed to linger and others where it vanished entirely. Over frozen rivers, the cold air near the surface contrasted sharply with slightly warmer layers above, bending the acoustic waves in ways that allowed the sound to travel farther than usual while distorting its arrival. Dense coniferous forests along the river reflected portions of the wave, scattering it across valleys and giving the impression of rolling overtones that travelled both horizontally and vertically. These atmospheric quirks helped to shape the eerie simultaneity reported by pilots and radio operators, deepening the sense that the sound existed everywhere and nowhere at once. Observers also noted a temporal anomaly in perception. In some valleys, the boom seemed to arrive slightly delayed, while in others it appeared to emerge simultaneously. Temperature inversions may have bent and channeled sound waves, but calculations showed that even the most favourable atmospheric conditions could not fully explain the simultaneity recorded across vast distances. Pilots reported the sensation of hearing the boom directly above and below them, an impossible spatial overlap that challenged conventional understanding of acoustics. Historical records offered little comfort. Decades of Siberian aviation and meteorological archives contained occasional reports of unexplained nighttime detonations, often dismissed as distant thunder or sonic misperception. Yet none approached the intensity, clarity, or reach of the Ust-Kut event. Researchers combed old logs for precedent. Isolated communities noted booms in winter, sometimes associated with ice-breaking or landslides. But the combination of timing, propagation, and lack of visible cause in the Ust-Kut incident was unprecedented. The human response was as remarkable as the phenomenon itself. Remote workers and surveyors described a tense, almost reverential silence following the sound, as though the landscape had been briefly acknowledged by an unknown force. Wildlife reacted sharply. Flocks of birds took sudden flight, hares bounded across frozen clearings, and even wolves paused mid-step, ears pricked, as if listening for a signal humans could not perceive. The simultaneous reaction of humans and animals heightened the sense of a momentary alignment across species, one triggered by an event that would leave no tangible evidence. Scientists proposed theories ranging from distant meteor impacts and ice quakes to acoustic ducting or sonic mirages caused by temperature inversions. Yet none could fully reconcile the recorded intensity, simultaneity, and tonal quality. Instruments placed in the field remained silent before and after the event, and no subsequent observation produced a similar sound. Even the suggestion of a controlled explosion seemed improbable. There were no settlements, industrial activity, or test sites capable of generating such an effect in such isolation. The region's remoteness and the sheer improbability of human error only deepened the mystery. Decades later, the Ust-Kut midnight thunderclap remains an unresolved entry in aviation and meteorological records. It exists in logs, in photographs of snow vibrating under its passing, in audio traces that defy explanation, and in the memory of those who heard it firsthand. Scientists continue to debate possible causes, but the event retains a singular quality, a sound both immense and fleeting, travelling across Siberia in silence, leaving only the questions behind. The midnight thunderclap vanished as abruptly as it arrived, yet its echo persists in the minds of those who heard it, hinting at forces in the wilderness that remain unseen and untamed.